find a solution. So, oh, I have to. So I understood that some of you have asked about slides, and I'll definitely make them available. Only problem is that these are often very big files, particularly if they're video. So I have to kind of do some cleaning up before I can do that. If I get time, I'll do it today or tomorrow, so that you can use them, preferably today. So if you want to prepare for the quiz, you have all the slides, okay? But I don't know if you will be able to easily download, because they're often, as I said, big files, okay? So I'll do my best. But I definitely am happy to review any questions, okay? All right, so as I said, there are diagnostic and therapeutic technologies. So let's talk about therapeutic technology, and more realistically implantable in this case, because for the nervous system, of course, there are non-invasive technologies also. But the trend, such as in an implantable pacemaker, now here is trend for a implantable brain stimulator. So how do you build one of these devices? How do you build an implantable neuro device? So what's in there, right? So first of all, it's in a titanium can, titanium box. Why do you think it's in titanium? It's inert. What is another thing about titanium? Okay, biocompatibility is same as inert, very strong, non-corrosive, and so on. However, working with titanium is also very difficult, and one of the most important things they have to do in designing such a device is to make it what's called hermetically sealed, which means no humidity at all can get in. So it has to be sealed perfectly. If any humidity gets in, it will short circuit the electronics. And what is body? I mean, body is warm, humid, salt. What happens when any metal is put in warm, humid salt? Corrodes, right? Degrades very badly, very quickly. So it's the worst degrading environment you can imagine. And so in that sense, inert thing. But if you take gold or platinum, they're too soft. There's some other, silver is toxic. And sometimes tungsten is used like for microelectro, but it's again not as inert or corrosive. So in the end, answer is titanium. So to make that can, it's very expensive, very difficult. Because yes, really it doesn't work. So people have tried to do packaging in variety of polymers. I mean, plastic is a general word for polymers, and something like a silicone is a polymer that can stay in the body, but it's too soft, and it is porous, so which means water can get through. It cannot be hermetically sealed. So yes, it is biocompatible, but it's porous. So plastic doesn't work. Ceramics, if it's considered ceramic work, and not for like 10, 20 years that titanium would work, but glass can also be a very good insulator. But it's fragile, and titanium is good for 10, 20 years. So it's the preferred solution for all implantable pacemaker, defibrillator, deep brain stimulation, all kind of devices. But I told you about Bion-like device, which is a muscle stimulator, can be packaged in glass because you don't implant it for too long. And ceramic is already now being tried, because if you are in a metal container, can you transmit data or information wirelessly to it? Because metal can becomes essentially insulation, like a Faraday cage, exactly. And so if it's in ceramic, then you can have an antenna on the ceramic, and therefore you can transfer data, but it's not as perfect insulation as metal. The other part of it is this, use the word plastic, but I mean there are certain type of, there is electronics in there, but you still have to connect the lead, the wire that goes to stimulate. So that connector is very, very challenging, because it is the weak link between a metallic lead and a titanium can, because you need to get that wiring, the electrical wiring, to go in. So what's called feed through. It should feed through. Do you all remember when one of those space shuttles blew up? Any of you remember? Challenger, well, Columbia later, so Challenger. What happened to the Challenger? No, that was Columbia. Columbia had the heat shield, the first one. It was on the launch pad, and in Florida, the temperature went down below almost freezing. So what happened was that if you have a rocket which has different stages, stage 1, stage 2, it's made up of parts and then cylindrical parts, and they had what are called O-rings. The rings are between parts to provide a buffer, and then they are sealed and all of that, but the sealant in the cold, freezing cold, became brittle and leaked, and therefore when the rocket took off, the super hot air leaked out of that O-ring area, and eventually it exploded. So these kind of O-ring, the connections are always the weak link. So this is a tremendous technology for making these kind of feed-through connectors that are inert, and still, because you are inserting something into a titanium, so anything can leak through that, right? And so how do you keep it totally sealed and leaked? It's very advanced materials technology. So there are, at least from outside, 2-3 parts like this long lead made up of stainless steel or such, so it's compliant and flexible and still inert and can flap, because if heart or brain it moves, it's very compliant. And then this kind of plastic feed through, and then titanium can, and the feed through has a lot of parts to it that it's hard to describe. How is it powered? What kind of batteries? So lithium polymer, lithium ion type batteries, these are the super powerful. In fact, nowadays we think of the batteries for the phone, laptop and phone and so on. Well, some of the first best high density batteries were developed for implantable devices. So they had the need, and they didn't mind paying a lot of money for it. So it's how it started, but then now the volume has gone up, and the technology has gone into other areas. So now you can see that they have gone down this path. Now, it's still, the stimulator is relatively big, and so you couldn't put it inside the skull. And so they went down this path where stimulator is here, run the lead, and then stimulating lead or electrode goes inside the brain. I mean, frankly, it potentially can be miniaturized. And if you look at pacemakers, there is a pacemaker now from this company Medtronic or Micra, which is really like Bion-like pill, very tiny pacemaker. But in a commercial business, sometimes there is no incentive to modify a highly successful product. Why? Company has made this product, it works, it's very successful. We know it can be improved. It can be made smaller with better electronics, newer batteries. This is stupid, right? This surgery like that, so you can just put it under the skull if it's really miniature. The electrode that I'll show you, it's very stupid. There are 4 electrodes. You can have 16, much more flexible. Why do you think the companies don't continually improve, right? If you go buy a laptop or buy a phone, there's always a model every year. Well, yeah, so by far the biggest deterrent is the regulatory process. And FDA, Food and Drug Administration, is the key agency for any medical technology in US. A lot of it is US based. It's the biggest market, so they want to always tap the US market for money and profit. So FDA is extremely rigid, conservative about performance, safety, efficacy. So any change requires significant revision and effort, and very costly. So they are reluctant to do that unless it's huge and extremely significant. But there are other practical reasons. Why would a company not improve and come up with a model? When you guys were not born at the time when I was talking about, but when I was young, there were only 2 cars in India, Fiat and Ambassador. That's it. So Fiat was small car, Ambassador made by Birlas was a bigger car. Yeah, that's it. Huh? No.
People they look at other people, what they have, and successful.
I don't think it was people.
Single product manufacturing cost is very high. So at a time, large number of production is happened, so it needs to be.
So why?
They have no incentive to. No competition.
Well, that's why they didn't get modified, because there was no competition, so no need to modify. So every year, ambassador would change a color, change a little metal piece here to there, make light this way and that way, cosmetic changes. The root of it partially was the government in its wisdom was very socialistic, pro-Neuro type government. You know, India is made up of a lot of poor farmer, rural area. You don't need cars. That's only for all these rich bourgeois people. So we need what, 200,000 cars? Let's create a quota. So 100,000 to ambassador, 100,000 this. That's it. So it disincentivized the growth. And it disincentivized the companies to adapt and modify. And so on it goes. And then people get resigned to it. People will take. So rich people would bring, will import Mercedes and all of that for very high cost. But as soon as there was an opening by the future government, all of a sudden, Maruti and whatever, all these Japanese cars and everything came, and suddenly now there's a wide availability because demand actually went up. So that socialistic notion is demand is fixed, but demand is not fixed, right? So that, but anyway, I don't want to get political. What it does is that companies have, not necessarily you would think, don't have an incentive unless they compete. So if these guys have a very high monopoly, high cost, very profitable device, why change it? Unless there is competition, they won't change it. So why is there not a competition? It's such a terrific technology for treating Parkinson's and stimulation. Why isn't other companies making it? Not really, because there are many companies making pacemakers, defibrillator, implantable. There are subcontractors who make titanium, ceramic, platinum.
They buy the patent.
Exactly. So it's one of those things about intellectual property means that you can create a bit of monopoly for a period of time and control the marketing, and then you can get a lot of profit. Then once the competition, because either patent expire or they get bypassed, so instead of lithium battery they use something else, or instead of ceramic they use something else, or small changes, container round and they make it square, they have to do some changes, then maybe there is a chance. And eventually mainly patents expire. So by then company is forced to come out. So there you all have to become very smart. Many of you will go into industry. Some of you will be inventors, some of you will be manufacturers, some will be marketing, some will be doing entrepreneurs. You got to learn this. And one of the problems in the way we teach you lots of equations and lots of biology, and we give you lots of tests. We don't teach you practical things, how to make profit, how to compete, how to communicate, right? Remember 2 days ago I said communication is the biggest challenge. So this is why I'm taking side thing, because these slides you have seen, but it's not about technology, you need to understand. So why do you think this technology is not developed in India? Why is it generally important?
High fabrication cost.
Sorry?
High fabrication cost.
That's possible. Realistically, it's high cost and
Approvals from the agencies here.
sorry?
There must be an approval from the agencies.
Once FDA approves, a lot of people will do that. That's such a high bar that sometimes they go for local and then eventually goes to US, the opposite. So what happens is that market is small and the manufacturer cannot set up for a relatively small market. It's a bit of complicated situation, right? There are hundreds of thousands of people in India get Parkinson's and they make hundreds of, it would be a huge market. But then there's affordability. So then an implantable device in US might be about $20,000 and total cost after surgery, rehab, this might be $50,000 to $80,000. That's not going to work in India. So a lot of costs may be inflated, high profit, whatever, but still. So if you lower the cost, the market might go up to a point, right? It has to have disease. People should have Parkinson's. So Indians may or may not live as much as some of the Western countries where Alzheimer's and Parkinson and other things show up. They show up late in life. People die at 50, 60, 65, you won't have the problem. So while Indian market can be huge in some way, it's not ready for some very high tech because of cost, because of volume, acceptance. But there are others, you are implanting something in the brain. So it's going to, let's say, even if they reduce the cost for India, and so $10,000 instead of 20, It's still a very small percentage, right? So those people who can afford $10,000, they can also afford 20,000. So my younger days, right, either you had fiat or ambassador for quota, so you had to wait many years and you got it, or people who imported had the highest end Mercedes and few cars. Because if you have that capability to import with a huge amount of duty, you are so rich you don't care. So coming back to medical, you're happy to spend a lot of money, you don't care. And then there is a mindset. Oh, maybe it's made in India, maybe it's not so good or not so reliable. Let's just get this imported best material, things like that. Yeah, so there's a lot of socio-political matters in such things. The companies like this making that are probably monopolizing and making sure no competition comes up. As they say, a world outside is what they call dog-eat-dog world. It's really competition. It's, imagine I can sell this versus that, and if answer you get this, you'll get very charged up, right? Because it'll suddenly create a competition. India, Pakistan, left side, right side, whatever. But when there's no competition, everybody becomes comfortable. And so there are some delays in introduction, but it'll come as country becomes more prosperous, people live longer, their purchasing power goes up. These are the frontiers. Your generation, if you're ambitious, lucky, learn, may do it, right? And of course, industrialists will figure out some ways. Okay, so I talked about these deep brain stimulation, different parts in it, and electrodes are very critical because they also have to survive in the brain and other tissues. You know, there are other stimulators for spinal cord, for pain. Spinal cord is also, I didn't cover many things, it's the same slides, but you know, people get a lot of back pain, right? You must have heard some older people in your family house. Back pain is one of those strangest things. You cannot actually really easily find what is the cause, and makes life very difficult. So there are these devices for pain blocking, but there are other devices to make, well, surgeons will fuse the spine. So they'll take the bone and fuse it so that it gives a rigid support to the spinal cord. There are others who put metallic mesh like a cage. So a stent, anyone know what a stent is? Yes, so what is it? What is it made up of? What is it? It's a kind of metallic. It doesn't have to be platinum. Platinum is too soft. So you know, there are nickel titanium it's called, and there are certain metals. It's like a mesh to go into the artery and keep the artery open by its strength. So that's a stent. And same way for spinal cord, similar metals, they make a cage out of it to grab the vertebra and keep them in place. So you know, I'm hardly covering the technologies, but there's so many such technologies being developed. Yeah, I discussed the cochlear implant, right? So now look at it in a little detail. The wireless, acoustic or wireless communication, external device, internal device, so you can see step by step. So you know, you can convert the sound into, and it might be a directional microphone, there could be noise cancellation microphone. You need to have a speech processor. Convert this speech into frequencies, right? How does a cochlea work? The cochlea it's like a spiral, but it is like low to high frequency. So if you stimulate here, you get a low frequency tone. If you hear, it's higher, here very high. So now you have to convert speech into like Fourier analysis, different bands. And somehow in the brain, all that gets fused back again into sound perception. So because it's so big and you need an extra microphone, of course it's in two parts, outside and inside, and then the cord and so on. All right, so I think there's a quiz question. So what does it simulate? So cochlea, I should have said cochlea, but anyway, hair cells are actually the sensitive part of the, so in the cochlea actually there are cells. Cochlea is the organ like a spiral. Within that, the substrate is what is cells, but the cells have hair like structure sitting. It's not literally hair, but hair like structure. So when the sound comes in the cochlear end, there is a canal. The sound travels like a wave through the canal, and that waves in the canal are picked up by this hair, and as they vibrate with sound, they produce electrical voltage that becomes a nerve signal to go up in the brain. A cochlear implant, of course, substitutes just like for retinal prosthesis, you substitute rods and cones. The cochlear implant, when the hair cells are usually they are the damage. What causes hair cell to damage and why people in old age get deaf? What kind of things would lead to bad hearing?
Exposure to very loud noise.
Yeah, you guys listening to headphones, loud music, concerts, lot of traffic. Yeah, continuous noise, traffic, and also, by the way, certain drugs and medicine they are actually have a secondary side effect. They kill so it's a very sensitive organ. And you know, how fast is a nerve fiber? I'd given you a speed. Anyone remember? About 200 meters per second. Super slow, right? So if you convert it into that, it's sort of each spike is about a millisecond, right? About 2 milliseconds. That's really slow, right? In the cochlea and here when I'm listening to the sound, somebody speaking from there, then there is sound in left ear and right ear. There's a microsecond delay difference between the two. Based on that, I'm able to place the sound there versus here. How is that possible? Because if an action potential spike is a millisecond, the electrical nerve signal is traveling at only about 200 meters per second. I already told you that there are many steps, right, from hair cell to cochlea to this other mid region of the brain, just like brainstem. In this case, there's something else, and then goes to the cortex. Amazing. Can you imagine if I have sound coming here and coming here, and they are off by a few hundred microseconds, but each pulse is a millisecond. Can you think of a way that I can actually tell whether there are a few microseconds?
Maybe wrong, but the cochlea also manage our posture and position, our 3D space.
That's different. That's for what's called vestibular. That's for balance. That's a completely unrelated topic. I'm glad you brought it up. I can talk about it. How can you, sound is coming, so as soon as sound comes, a pulse is produced. Another sound comes, another pulse is produced, left and right, let's say. How can I, when these pulses are about 1 to 2 milliseconds, I can difference the sound arrival by few tens to hundreds of microseconds? Okay, kind of latency to what? Latency where?
Peak origination.
Latency between what?
Spike originations.
Which spikes? I think probably, maybe I think you're getting it. I just want you to be really clear, because you know I'm about to give out the Nobel Prize and I don't want to give it for incorrect answer. So, sorry, somebody. So you said there is a peak here, there's a peak here, but how does the higher part of the brain looks at the two peaks and say they are off by a few hundred microseconds and
Auditory nerve carries to auditory area.
yeah, it goes to the brain, but that's by the time already too slow. There must be something so that you can tell that these two peaks are separated by. No, the frequency, there's one pulse. Superimposition or coincidence. So if you have the slighted, so what likely is possible that there's a coincidence detection cells. So remember way back I showed you the picture of dendritic somatic synapses. Now you can imagine if two synapses come to a cell and if they are identical, you get perfect timing, you get 1 voltage. Even if by few microsecond off, the voltage that the cell or the dendrite produces might change, and the further apart you go, the voltage might be different, more or less, whatever. Coincidence detection. So there are probably schemes like this in the brain and many others that allow you to process things at a very high speed irrespective of the fact. It turns out that these hair cells are not just passive hair cells, they are dynamic. So they themselves they create resonance. You guys know, right, what is resonance? So with the resonance, the peak gets stronger. So a lot of interesting technology and things inside the ear. Okay. Okay. What? yeah, you need all of the above. Of course, wording is a little bit relaxed. And retinal process, as I said, generally the pieces are, you'd have a camera in your eyeglasses or somewhere. Camera's image or something is then can be projected. That's sometimes one way, or more likely converted to electrical signal by a chip, so that it will stimulate. So light comes through, goes to the chip, it processes the light, and then breaks up the pixels into this 10 by 10 or 30 by 30 array. And so if there's a letter E in front of it, essentially these 30 by 30 electrodes will be stimulated, and they would provide a perception. It's called phosphines. It's a artificial perception of light, by and large black and white. There's no big intelligence, there's no motion and so on, but as I said, about at 30 by 30 you can kind of tell that there's a person there, or there's a door, like bright room wall and a dark door, so the person can walk through the door. Although some people in videos have been shown to shoot basketball, somehow brain learns, and even with 30 by 30 it picks up amazing resolution. But it's eventually still limited, because the retina is small, but that's not the issue, or microelectrodes are small, but the current you are injecting to stimulate, that adds up. So these things are it's very, very sophisticated to pack it all in a very small scale. So people designing are doing these IC designs, microelectrode microfabrication, a lot of optics, and then of course typical wireless and packaging. So it stimulates the ganglions, and rods and cones are usually gone. There are people because this more or less is covered by patents, and the current company dominates that. So there are some effort, like when I was in China, they were trying to build retinal, but it never took off. It just was a way to get around it. And the very first idea, Dobell, I think that kind of names some in the morning I was confused, but there's a guy called Dobell. He did the first stimulator to the cortex. So he directly stimulated the cortex. It was about 30, 40 years ago, maybe more. In those days, rules and regulation were not so difficult. So now you know, right? So current density is a limiting factor. Of course, in the end, battery power is the limiting, because eventually you run out of battery, but maybe you can create different. They're all important, but limiting is that. Bions are pills like devices, because they're rather big, but you can go through the skin and insert in a muscle. So if somebody has a nerve injury and the muscle is sitting there but not able to function, this is a bion is a little tiny stimulator that provide a contraction to the muscle. And and so of course it to make it small, you can keep all the intelligence outside and just keep the stimulator and battery and all of that. And most likely some part of it is battery, some part of it is wireless delivery, and then a couple of electrodes. And the wireless part may have ceramic, and the rest of it is in glass. So it was a rather interesting technology. A little loudly. That's good. So it's for muscle. It is nerves require very different kind of technology. They're very small. Nerves stimulate by very tiny, narrow pulses. They're delicate. Muscle is more robust, higher current, all of that. And directly stimulate muscle leads to actuation. However, if you can successfully stimulate the nerve, it's very efficient, because it acts like what they call amplifier. The nerve takes a tiny signal and makes large muscles contract. So deep brain stimulation has many different topics, and we discussed all of this, so it's nothing new. Maybe the website might or YouTube might be interesting. Stereotactic surgery, so they would implant using this kind of it's called stereotactic surgery. So the head is perfectly positioned, so before the operation an MRI scan is done and obtained in 3D, and then the patient in the operation is precisely located in 3D space and fixed, so he won't move or she cannot move, and then the real brain and the MRI image are superimposed, and then you go precisely within millimeter to where you need to go. Precision surgery, so that's why robotics has a value, because you need to go in a precise way. If you're off by 1 or 2 millimeters, the deep brain Parkinson stimulator won't work. So surgeons have other tricks also. Yeah, see, I've suffered enough. I've made life easy up till now. So it's E. We really fully don't know. It's certainly, they're not stimulating some kind of there is no motor circuit in charge of movement, because it's a highly distributed control system. Stimulation doesn't release dopamine, although you could sense dopamine and adjust the stimulation threshold. That may be interesting, but again, because of that monopoly and all that, people have shown it, but no, it's not made into practice. You stimulate, but it doesn't mean it affects entire brain function. It just affects local circuit in basal ganglia. It doesn't repair the motor cortex. There are other conditions. Dystonia is also another kind of rigidity. Even thought that MS could benefit, although again it's pretty much unproven. Depression, treatment resistant depression, which means they would always try drugs first for this or epilepsy. But it doesn't work, then you get devices. Oh, deep brain stimulation may improve memory. Why not? Let's have a stimulator before exam. There is interest in these things. Improve IQ, attention. Obsessive compulsive. There is people who just can't stop eating. You can stimulate some part of the brain, and it does potentially reduce the obsessive compulsive eating disorder. You may know of some people, right? Super fat, eat a lot. Would they get a stimulator like this? What are the treatment of being obese, fat? So there are, so treatment, right? I mean, good lifestyle and all that, but it's very hard. Most people can't handle it. So they're liposuction. There's something called bariatric surgery where they cut off some of the intestine. Diet control. You're too much an idealist, I mean, how many people can manage keep a diet control? Before you go to Rasgulla comes and that's it, diet goes by the way. So it's very, very tough. The fat cells just go dormant and they come back. Exercise and all that is good, but doesn't last forever. Yeah, it could be, but is it worth a brain surgery? So the idea had some validity, but hasn't taken off. In this, there are a lot of links. They may or may not be active, boosting memory, this and that. Okay. So the broad questions are many of these things. Maybe you can come up with your own idea or application. These are just general questions. Okay. All right. Yoga time. While I switch gears. So we are going to go into a sort of small module. There's a bit of an afternoon effect. So it means you all have to help change, the monotony of my talk, right? Yes, but questions are the best way.
If the mechanism is not known of DBS, then aren't there any side effects of it?
Possibly. Possibly. It's not so much that there is a side effect that has been found so far, but more like habituation. So after a while it may not work so much. I would say the biggest is actually the risk of surgical implant, that after all these, the electrode is not positioned, may not work, or infection, the cause, those things. But rather it isn't like, okay, you implant it there for your tremor and suddenly you start jumping or go crazy, start dancing. It doesn't misbehave like that. So it works extremely effectively, but there is in this whole dopamine business, like for the drug and all that, there is habituation. Parkinson itself is a bit of a degenerative disease, so at some level there is a loss of cognitive ability as well, plus physical frailness. So these people, to start with, are older, and as they get older and older, they get frailer. Any other questions? Okay, give me 2 minutes. You know, you should need to make up some couple of questions. My laptop has slowed down a bit for some reason, so give me a minute. At the moment, although they will eventually feed into clinical medical products, you know. Okay, so we'll talk about implantable micro neurotechnologies. So I'd shown you some picture like that before, but anyway, what you see here is a little small microfabricated, MEMS fabricated is called electromechanical systems, you know. So what the technique is to make things at a very small scale. So for example, each of these little probes might be 100 micron, the entire thing might be 1 or 2 millimeters. So nerves are about 100 micron to less than a millimeter. And so it's go around, it's also flexible. So there are materials that are out there. Silicon is rigid, but polyimide is a material that's flexible. So you can make things flexible here. You of course need IC chips and you need wireless electronics, and I'm going to show you some videos to explain this. So when it's all put together, the electronics goes into this kind of a package like on a circuit board. In this case, it's sealed with silicon-like material. There's another material called parylene. There's a lot of interest and research in trying to make materials biocompatible. Silicon, parylene, all of these. Again, they don't last 10 years like titanium, but they last for, you know, 3 months, 6 months, something you can work on. So in this case, this electrode that was here, you know, something like this, and then fully assembled is now packaged. The IC chip is here, and this has been implanted inside this. Although the larger wireless electronics is here, and then you can record. So you know how you fabricate. This is an IC chip. It's also called VLSI, very large scale integrated circuit, because you can pack thousands and tens of thousands and nowadays millions of transistors. You know? Of course, for biomedical you don't need millions, but modern computers need them. For biomedical you need like entire EEG amplifier, neural amplifier could be here. In fact, maybe 16 channel amplifier with a lot of stimulation electronics and all of that. But what's unique here is it's been sealed. There is a sealing of the device so that it won't leak into it. Not like titanium, so it will last for 1 to 3 months until water, humidity will make it through. But many of these things we do animal research to test it in a rat or something, and then it's pretty useful. So you see how these microelectronics are fabricated. Like IIT Kharagpur would have microelectronics lab. There are people who know how to design chips. There may be microfabrication MEMS lab where they can do this, but trying to put it all together is a very big challenging project. So a lot of funding needed. This is another kind of thing. So you can see that electrode like this can go around the nerve so that it can be very flexible on the nerve. So when you put the electrode on the nerve, again, it's about 2 millimeters. So you see that there's like a large nerve. In your leg, what's called sciatic nerve is large, and it produces, if you stimulate, it produces this potential. You know, so apply 0.3 didn't work, but about 1 milliampere. there was a signal. So you can stimulate the nerve. This is how implantation could work. So here is a nerve, and that's that electrode that you saw before. This is a new kind of electrode that wraps around this nerve. So sciatic nerve has 3 branches, and now they get smaller and smaller. I think this is probably 2 millimeter. I'm not sure. So they are a few hundred micron. Can you imagine making electronics? This is some of my students postdoc do that, and then this particular electrode, which is here, packages to the connector and then the circuit. So you see the miniaturization of all this. So nerves put completely different kind of a challenge because they are so small compared to heart and brain and spinal cord. So it's a very new cutting edge research area. We are trying to develop these new kinds of electrodes that wrap around the nerve, and flexible nerve electrodes and so on. This is what an IC chips looks like, IC or VLSI or something, where all the transistors, and these are like bonds, so pads, which means the circuit, all the transistor here, some digital circuit is here, and then the signal can come out. So on this there might be few thousand, tens of thousands of transistors to make this. So this particular one is works with 3.3 volts, draws very little current. See, for implantable you need very little current. And then it has a 8-bit A to D converter, all on a chip. Then I've shown you this picture before, put it all in a sealed package. The wire goes for stimulator, stretchable, and then this is the antenna. This is like a first generation large device. This is second generation small one. This one is a chip, VLSI chip, which is 8-channel amplifier and a 4-channel stimulator. So you see, can you imagine? Right? If you go into a lab, 8-channel is a big box, 4 channels, to make it all. And now it's all on a single tiny chip. So this is IC design is even here, there are everywhere there are classes that would teach you. Now, unfortunately students here cannot generally, I don't think they can take it all the way to fabricating it, but they can design these things. So if you want to build implantable system that are small, you need some super small designs. And then I showed you this video, if it works, right? So now the whole implantable system works because now you brought the external coil, which induces electromagnetic induction, induces the voltage in the inside coil, which in turn then powers the chips here, which takes the signal to the electrodes, which are connected to the nerve or muscle fiber or whatever that you're trying to stimulate. Everyone now understand how this, remember I showed you this 2 days ago? And now all of a sudden you might say, oh, I think I sort of know the pieces, There's a little induction, there are coils, the coupling, the implantable, I know that this is a chip, this is an antenna, it has to be flexible, all of that. All right, quiz. What is MEMS? So which one is it?
B.
I think I'm making it too easy. I mean, you didn't go for meta electronics or meta substances. It's MEMS, no? All right, okay. Oh, boy, you guys are so smart, amazing. This is like, woo, these guys is like totally the smartest group. What are the, okay, let's make it a little bit tricky. There's a, first answer the part outside and then we can discuss the bracket. So what would be preferred by you if, do you think that these are all suitable ways to power an implantable device, or you don't like any one of them? You don't like it? But it'll work forever, 100 years. But you can seal it.
But the seal would be lead and very bulky and all.
All of the, more or less all of that true, but what is the biggest reason not to do it? Yeah, all of those are true. Fair, maybe, I'm not sure, but that's right.
How to make it that small?
There's, you need a little tiny nanograms worth of plutonium and you're okay probably for the 10.
It would be better if it is charged by body temperature itself within the cell.
That's a different topic, we can talk later. Sorry, cost? I think it's a social acceptance. Nobody likes radioactive something in their body, right? So it's, so what I'm saying is that you need to learn in this classes and modules I've taught you, so the other things outside of technicalities. And many of you who are not going to design ultrasonic or whatever, you will have now, I hope, an improved judgment to pros and cons of such questions. And I'm trying to do something is to develop some thinking skills, some critical analysis. So you can take such questions and look at various sides of that. So if you can apply critical analysis here, someday when you are designing, plutonium based autonomous vehicle, you'll apply the same judgment, So I think it's like in space program, for a long time, when the space they have to go all the way to whatever, Saturn or something, the only way to deliver is plutonium and so on. But in the beginning, there was so much fear that what if that during the takeoff plane blows up and then all the plutonium would be this. There was a lot of resistance. Somehow NASA got through that. Somehow they did it quietly. Maybe they improved the reliability to the point where maybe public stopped looking. But radioactivity hasn't taken over. So by and large, other than nerves, everything the battery operated works, because these batteries are so good and they last for so many years. There are micro batteries, but nerve interfaces are so small that it might be a bit different. So radio frequency, or what's called electromagnetic induction, is the most common. They communicate with pacemaker using magnetic fields. So you have a pacemaker and you want to change its program to a heart rate of low or high. How do you reprogram it? And titanium can, so titanium is still so much more reliable, and ceramic is not up to that level. So they can then use magnetic field, clicking magnetic field and magnetic relays or something, capture the message. So actually magnetic works, and more recently people are able to transmit ultrasound, because ultrasound, like ultrasound imaging and others, travels very deep in the body. Sound travels well in air, better in water, excellent in solid, right, in the body. So ultrasound can be a very good thing, and radioactive is controversial, but you never know. Okay, so I think we are kind of skipping through these one step by step, and I think it's 5 minutes to 3, so we should have about 10 minutes of human, what they call bio break, friendliness break, take a nap, and let me just tell you what's coming now. So something stops. Sorry, my laptop has slowed down for all this switching. Lecture, so we are up to now lecture 10 and 11 we finished. So 12 and 13 are neuromodulation, and that's something we have more or less done, so that's pretty much okay. I'm kind of a bit reluctant to go into BMI today because it starts, or I might just, depending on time, because neuromodulation is a bit repetitive, so we could just do BMI EEG today and then pick up BMI advanced material tomorrow, then sensory and motor prosthetics, and then peripheral visceral, so nerves, and then tomorrow afternoon would be neuromorphic, so brain inspired. So it's 3 parts: touch, vision, and superhuman performance. I don't know what that is, I'm going to figure it out. And then last will be cognitive engineering. Okay, so tomorrow is what, Thursday? Oh no, that's it, we are done? Oh no. Oh yes, thank God, now I can go home. Okay, so all right, so that's it. Then on Saturday I have to leave by 11, so we will have a couple of 8 to 10. Professor will decide whether you all come early. I know you don't like to come early, but it's the last day, and I really have to leave at 11. So the idea would be for us to give you, tomorrow evening will be a quiz, then Friday some awards or whatnot, and and then my last bit of talk on summarizing and all of that. So that's our overall plan. Okay. I did ask you all to give me some feedback. I haven't received a single one, so obviously I'm perfect. I am the best. All right, so take 5-10 minutes break, okay? But I welcome your feedback. Oh no. Sorry, I'm having some problem with my laptop, so just be patient. Okay. Well. So an implantable electronic system, let's break it down into little parts. It has little micro sensors, microelectronics like VLSI circuits, recording circuits, stimulation circuit. So so if we look at this is a kind of like an entire system, right? If I want to restore the hand function, now I need a neural interface. I gave you some example of electrodes that can go around a nerve. You need microelectronics, which would be preferably wireless. You have to decode the information from the nerves so that we know that if the message is coming from the nerve, it can be carried to the hand where we stimulate. So if I want to move my thumb or move my fingers, and then hopefully in an ideal world, it could lead to hand dexterity. So if you remember again from a couple of days ago, there's people who get brachial plexus or those kind of nerve injury from accidents, from infants to birth. So this is the kind of treatment you can have. So what are our step-by-step solution? Making these microelectrodes, neural chips for recording and stimulation, wireless data and power. So let's show that in action. So here you see. So what happened was that there is an implantable stimulator that in a sequence of pulses giving what is called tetanic pulses. So step by step, and you create a progression of electrical pulses that can actually contract the muscle and the leg moves. This will work in Singapore, so there of course you can imagine rats are playing football, I don't know about Indian rats. So you can do the leg movement that way, but you understand the principle. You in a sense can do the same thing with monkeys. You can move individual fingers, because you can put the stimulator on individual fingers. So of course you take the signal from a nerve and then say go controlled. So someday, this is all very preliminary demonstration, but someday we can have, if monkeys can move and then it's playing piano in a programmed way, but hopefully people with these kind of injuries may be able to do kind of dexterous manipulation. So what you see here are these are the spikes, those nerve signals. So you see this monkey is grabbing a hand. Okay, I don't know, maybe you can hear the sound, but you know, it's because we convert these spikes into a sound, so we get a feel for how it's going. So you see, every time monkey is trying to grab it, there is a nerve activity. If you hear it, it's got a coincidence that there is a yellow dot going. So that's the spikes. Now they're coming up. Again, it's going to close the hand. Again, there are spikes. So the point here is that nerve signals carry that information, and that's what is making us use that message. If we decode it, then we can control and stimulate the hand, which we saw here. So if people want to do this, they have to do a lot of these initial studies in monkey and then someday go into human. It takes 3 to 5 years, minimally 5 years to just do feasibility, and clinical might be another 5 years or so, millions of dollars. This is I was struggling with the video is messed up. I couldn't move the circle. So this is a patient who had nerve injury. He was a pilot and had some kind of electrocution or some kind of accident, and so both his arms, you'll see, hardly move. But what is being done here is some of the signals are being picked up, like muscle-like signals, and then they go and control the hand. The circle was meant to be here, but it's shifted, so you know, pay attention to this. So you see, he's really not moving, but so you see there was a signal captured as a command to close. So this is a demonstration that signals like this can be used eventually to control an exoskeleton. Maybe this person's weak arm would be covered with a mechatronic exoskeleton. At the moment we are just showing a hand, which would be then controlled. So you can move the hand or move even the arm. You see that? You see how the disability is? The arm is there, but it doesn't have any function or control. And now we are kind of getting some control out of this. Okay, so this is kind of like gives you an idea how this type of work, it starts with devices, then you do these studies in like rats, then do it in monkeys, and then someday go in the people, right? It's a long road, but that's how high impact work gets done. You know, nothing is simple, right? If you want to send a man on the moon, it's not simple. So all of these are rather challenging projects, large, multi-scale, and you know, probably in India, one such project can be launched, then it would change, you know, make a huge impact. You all know how to now build implantable, right? Everybody, no big deal, right? Yeah? Yes? Very challenging, but what did you get? At least I took some mystery out of it, right? At least you know some vocabulary. At least you know what a VLSI chip looks like, so if electrical engineer comes, you understand what they're talking about. Or you know now different types of powering techniques, that you need packaging and so on. All right, so neuromodulation, and we are going to deal with peripheral, right? We did talk about DBS and all that, so we are shifting to peripheral. So peripheral nervous system, we can divide into two parts, central and, well, I should have said nervous system, but it is central nervous system, which is brain and spinal cord, and then peripheral, which has a sensory division and a motor division. You sense a feeling of touch, movement. However, there is further division that's really important. So one is called somatic, which is like the body. You know when you move an arm, you know what you're doing. Other is visceral, which is more or less you can't control. The heart, the kidney, liver, they work on their own because autonomic nervous system controls it. So the visceral has two parts. Sympathetic means it makes it harder, faster, more challenging, which is essentially if you think about the heart, a sympathetic nerve will increase the heart rate. A parasympathetic on the other hand will lower the heart rate. Okay? So, maybe you know people who have blood pressure up and down. Could you control the blood pressure, high blood pressure to lower it, low blood pressure? So, this is the area, this whole business. So, it's I am going to give a word for it, electroceuticals or something, because most often what do people do? They control blood pressure by drugs, right, certain medicines. So, pharmaceuticals. But now it is an electrical device working like a pharmaceutical. But why that is even possible is because if we start understanding this complex things. This, of course, this is brainstem, midbrain. So, high in the brain, then there is an area called medulla, and a lot of nerves come out of that. You can maybe see the tiniest of the words, but some of these are going to the eye, the certain glands, mucous membrane. But around here, these nerves are going to the heart, and the red one might be sympathetic and blue one might be parasympathetic, so that fast and slow are balanced. The nerves also go to trachea, so that food can go down the stomach. Lots of nerves are going into stomach. It goes to blood vessels, liver, pancreas, adrenal gland, so on, intestines, kidney, bladder, right. So, pelvic nerve goes to the bladder, and there is another one called prudental, but this pelvic nerve can be controlled. So, it can, if you stimulate, you can properly empty the bladder. Now, of course, you do not want to empty the bladder, right, little babies cannot control and they urinate any time. Very old people also lose bladder function. So, you need to figure out how to control the bladder, so that by stimulation or blocking, you either if its bladder is leaking too much, you must block. If the bladder is not emptying, you must stimulate sexual organs and so on. So, it is all nerves. So, this is very hottest new field of neuroengineering, neurotechnology. There are words like that given to it: bioelectronics, bioelectronic medicine, electronic medicine, electroceuticals, but different people are using different jargons. An essential idea is to control the organs through the nerve. So, if this is a nerve and all this nerve fiber, the signal is all the spikes, but these spikes carry the message to the nerve or from the nerve, to the nerve to empty the bladder, from the nerve to see if the bladder is full, so that you should do something. So, this is a very emerging. There are very few commercial devices, mostly it is at the research stage. So, it is highly publicized in top journals like Nature and so on. Drug companies get into this because they say, well, revolutionizing technology. And there are many different, you see that the electrodes, chips, wireless, wrapping the nerves around, and let us treat all kind of problems. All right, so how do you get this all going? I mean, that sounds like a big deal. You guys are young, how can you get this going? Well, actually in US, people at your age are starting companies, so that is how it goes. But it takes a lot of teamwork and effort. I mean, most of you are sort of here, maybe an occasional young, innocent clinician or basic scientist. To make this happen, of course, you need a lot of funding to get going, venture capital, or large companies like Medtronic or somebody say, well, we want to get into this area. So, in this case, a drug company called GSK has gotten into it. And of course, willing patients. Do they want to implant? They don't want to implant, we have a problem. So, what are the pros and cons, right? Anyway, well, let us come back to it. I have a question for you later. So, this is where FDA you have to go through it. So, there is a weight loss device that FDA has approved. It's a company called Enteromedics, adults with morbid obesity, so 40 to 45 kilograms and all that. And they have developed this vagal nerve stimulator that conduit between brain and gut. In addition to affecting hunger, it also influences gastric relaxation, so gastric stomach relaxation, levels of stomach and appetite regulating hormones. Interesting. This is a little bit simpler vagal stimulation device. So, instead of making it, so this is implantable version, and the the little pacemaker like this goes there, and then the electrode wraps around the nerve. So the vagus nerve here at the neck is much more easily accessible. Inside it's much harder. And of course you can program it through remotely by electromagnetism. Bladder stimulation, right? So people, I told you there are two types of bladder problem: overactive bladder. So bladder is more very active. Again, women after childbirth, older women, that's perhaps generally more common. Or underactive bladder, which means it doesn't empty. And it's a serious problem. People who are paralyzed cannot control their bladder as well. So an external controller provides a wireless control to the bladder to various nerves, sacral nerve, pelvic nerve, and all that. The device pretty much looked like pacemaker, right? Titanium can, that little plastic or polymeric connector, feed through, battery, electronics all inside. It's a semi-wireless, so it's commercially now available. Fully wireless is very challenging, fully implanted. A lot of serious problems. See, you can see 51 to 59% of the elders, voiding 20. So these are big problems. Okay, let's take an example of what you can do. So this is one of my students built this IC chip, and it's like a controller. So it detects the heartbeat, and based on the heartbeat, it applies the stimulation so that you can control the heart rate. The vagus is the nerve that lowers the heart rate. So you see what is happening. I applied the stimulation, small stimulation, the heart rate went down from, so rats have a very high heart rate, not like us. So they have like went from 380 to 360, 340, all the way down to 280. See, you can control from 5 to 25% change in rate. Kind of fascinating. Bladder control. So if we are still simulating a nerve called pelvic nerve, and see when you stimulate, the urine comes out. So that's pretty good. This one is the opposite, blocking, but it's not interesting because nothing is happening. So you can also block the nerve. So when you stimulate, there's no urine will come out. So you see, these electronic devices that you're learning about very superficially, I understand. I mean, none of you, I can imagine, don't feel it easy to figure out how to do that. But obviously, if you came to lab like mine, you can see how this is made by different engineers, young people like you. They're making electrodes, they're making circuits, they're making packaging. Some are specialized in wireless. They team up and do the packaging. Then some people get experience in surgery on a rat. Some people clinical, others give some feedback. Large team. One of the biggest change that's going to happen in your life when you graduate out of that is you're going to work in big teams. You're not going to work isolated. Today, if you work on a team, what is it called? Cheating, right? Copying, cheating. So it's a very bad way that education works, where we force people to work separately and all of that. In reality, you really have to work together. You saw some example of how collectively you all give very good answers. Okay, quiz. Yeah, so if an occasional heartbeat missed, pacemaker corrects for it, because it just looks for the beat, the pause there, pulse it. So defibrillator is not because your heart rate slows down. It actually goes into a rhythm called fibrillation, where heart doesn't beat at all. You're dead unless you give a shock to revive it. So if the heart rate slows down considerably, actually pacemaker could work, which is current prevailing technology, just make the heart beat faster. But this sympathetic nerve stimulator is meant to raise the heart rate. Parasympathetic, like vagus, lowers the rate. I'd say emerging technology, not proven. Sympathetic nerves are very hard to get to. You're messing around with nerves which are very delicate. So today, this. Someday, something like this. Yeah, I did talk about that in passing, right? Remember I said when I showed that picture, I talked about pelvic nerve. In the big nerve picture, I was dropping hints for those who were listening. See, there is that pelvic nerve I showed you, which then goes to, of course, the problem is too complicated. Look at this nerve is going to intestine, it's going to the colon. So while you might play with bladder, it may also affect kidney or defecation and so on. But if you go sufficiently further down, it might be more targetable. But then it's very difficult. The nerves get smaller and smaller, and targeting is hard. So these are why these are challenging current research problems. Okay. So what I'm trying to show you is that you get both kind, underactive and overactive bladder. Overactive, well, then maybe you have to block it, or maybe there might be way to block the stimulate a sphincter so that it closes. So bladder and output of that is a sphincter, and the bladder works in conjunction with the sphincter. So when the bladder is filling up, the sphincter must be closed to allow it to fill. When the bladder is empty, the sphincter opens. So maybe you can use sphincter as a valve or side by side. A lot of these are unknown research done. The funny and strange thing is that there are some of these weird drug approaches. So first of all, there are drugs available for over and underactive bladder. They work in a pharmacological manner. Yeah, they tend to be expensive, they have side effects and all that. With these electrical devices, they're delicate, they're surgery and all that, but no side effects, either you stimulate or block. But there's something like Botox, I think this is also sometimes treatment, just paralyze the bladder so it doesn't get overly active. Botox is being used for cosmetics, you may know about it, but it has a lot of other medical use. So this question. All right, so your father, mother, grandmother, uncle has a high blood pressure is fluctuating, they can take drugs. Drugs do have side effects. They have a cost. I just took some arbitrary number. So you can see it's about 36,000 rupees a year. Sorry, my rupee symbol is very old fashioned, but I just picked a number like implantable system costs 250,000. It could be 500,000, I don't know. All right, how many for drug? How many for device? There's a bias here because of course it's a neurotechnology course, it's not neuropharmacology course. My feeling would be that most people will go drug route. So why do you think so? Sorry?
The stigma that's
People are used to implantable pacemaker or artificial heart.
basically it can be drug can be taken without any much alteration to do with day-to-day lives. But suppose you wanted to have an implant, you'll have to take a leave, have some pre-surgery routine or whatever.
The one time.
That it will take.
The drug is everyday headache.
That also comes along with the risks involved.
People are scared.
You're not scared of the drug, but you're scared of the surgery. Interesting.
Drug has a flexibility, right? Like in case something goes wrong, you can alter the drugs and you can change. It can be flexible with the body conditions of the body and patient. But with the surgery, once you do it and you can't do it again and again.
It's like 2 lakh rupees at once, and you see 100 rupees or 300 rupees per day. It looks very cheaper. It is not, but it looks very cheaper. So that's why
Both get the job done and one is like an EMI.
yeah, it's a EMI. Reliability data for electronic devices is low, but clinical trial data is present for drugs. So reliability.
So you guys should be listening. I mean, there are all kind of ideas. So the reliability of devices, although it's pretty good actually.
The price which is saying in 5 years it is around 5.5 lakhs.
Yeah, but you have to consider inflation, cost of investment, so all the money is being there. I mean, I could change the number just to suit you. Well, where am I going with it is, you're all discussing very highly relevant topics of different facets of it. There are a few others. The drug companies are incredibly, awesomely good at marketing. So they have these beautiful advertisements and so on, and they market like crazy. So people listen. They even sort of take the cardiologist to wonderful vacation in Maldives and to tell them that this drug is so wonderful, and of course every time, but the device companies can do that too. So there is a lot of non-idealistic marketing behind this too. But you all touch many different issues of perception of safety, social, societal, reliable. And this back and forth generally has gone, not every time head to head. So for example, for ventricular fibrillation and certain rhythms, there were drugs like amiodarone and so on, a lot of effect for that. Defibrillator was so good, they had to stop the drug. Defibrillator, really no side effect, reliability is awesome, good for several years, life and death, no question. Pacemakers have been very good. Artificial hearts, mechanical, versus mechanical, tough. The breath stimulator versus dopamine, you can take 5-10 years of L-DOPA, then efficacy wears off. But the implantable stimulator might also last for 5 years. So now, should you take L-DOPA for 5 years or something and then go to stimulator, or go for a lot of it decided often by insurance, political pressure, the marketing of the companies. So there are many broader factors that play, right? You are sitting here as idealist, later on you might work for the company and your attitudes will change, right? People working for cigarette companies are quite happy to say, oh, it's great. You can lose weight, you can make it wonderful, etc. But there's a different side of it. So you can see that this technology in insertion is a very complex process. Some of you are cost sensitive, some of you are risk sensitive, some of you thought about social, maybe you didn't think about marketing and profit, but you might start thinking about it. So new emerging technology, what seems to happen is that by and large they come with cost, although somebody did come and ask me about frugal technology, right? So it's a fashionable word for India, Africa. So what do you think? Can we create a frugal pacemaker? Definitely, you can do frugal pacemaker. Why isn't there a frugal pacemaker? No, that's an old-fashioned way of looking at it, is that, as young we used to say, made in USA, Ullasnagar Sindhi Society or something, I don't know, some stupid nonsense. No, that was an old-fashioned way that you can copy and therefore, or make it cheaper. Indigenizing comes at a reduction price. But now, Indian companies and others also get it. There's 7 sigma and 6 sigma and all that, they make it. So it's not necessarily that, but there is a tendency that you can have pacemaker with high super level of programmability, or a bare bottom pacemaker that does what it's supposed to do. So why is more likely than not they are higher end pacemaker rather than frugal pacemakers? Yeah, device companies, they don't have much benefit in reducing the cost. They want to, so they always want to insert new fangled programmable so that they can keep going. They do that with the drugs also. They introduce slightly modified, improved version of extra strength, super extra strength with low side effect, then make the pill pink and then red and then nice packaging and then some different beautiful person marketing it. So you get the idea that these are, you have to think of these things as a whole. Okay. Okay. So we have about 20 minutes. So I think I should be able to cover one module before our visitor comes in. Interesting, right? I mean, the field in this, and very likely, I hope some of these things may well be relevant to you later on, because you will very likely choose this common sense in your work. And what's the number one thing you're going to do? What did the Harvard people say? Communications. Have you guys making friends with each other? Yes. I mean, don't do something too far like get married or something. Just be friends. Okay. Communication, teamwork. You saw the power of collaborative teamwork. The results, answers were better. All right, so let's switch gears to BMI. Just introduction, and then we'll pick it up tomorrow. And as I said, tomorrow we'll do a little bit of BMI, and then we will go into neuromorphic and then cognitive. So neuromorphic later in the morning and cognitive in the afternoon, and then there'll be quiz. You've been asking about it. I'm going to put it all up. It's going to have to work very hard. I'm going to save it in a Dropbox. Will you all have ability to download, or somebody here would not have the ability? You can, right? Okay, good. So it'll be like Dropbox. You click and then download something. It'll be a lot of work because there are about 15, 20 lectures, and I have to get rid of. I'll probably most likely get rid of videos. That way, files are smaller. They're very big. Okay, so the sexy field of BCI, BMI. It's kind of sometimes used interchangeably, brain-computer interface or brain-machine interface. So ostensibly, of course, BMI is a superset of BCI, right? The computer is a machine too, but maybe sometimes people can think of BMI in like prosthetics and robotics, and BCI like pure computer, so you can move a cursor, type a letter by a paralyzed individual. All right, so let's get to know little pieces of the BCI, like what is BCI, what is the different architecture, what are the design, what are the applications, and so on. So BCI is essentially thought to action. That's generally in a simplest way. Can I kind of convert my thought into an action, right? And obviously it has one of its best uses maybe for somebody who's like completely ALS, paralyzed, and so on. So if you can see this, you probably pick up some brain signal and then do signal acquisition, processing, extract some features from the EEG type brain rhythm, classify the rhythm into A versus B, this versus that, and then create an application such as move a cursor on a screen, type a letter, turn the light on and off, move a wheelchair, move a prosthetic hand. Then some of you have started to notice it wouldn't be nice if we had a closed loop, like you could sense and give a feedback. But a lot of BCI is here, and this is emerging. So BCI, its coolness is that it enables communication without movement, right? You don't have to move, right? It's like the magic of it is mind to that. Now the interesting part of it is this. Could you have thought that right now, I mean, for example, I can pick up my phone, I look at it here, and I can call up, and through FaceTime or something, have a video chat with my son or daughter in US somewhere, although they're probably asleep. But you see what I'm saying? Who would have thought that this is a communication that's non-contact, non-invasive, right? But you're taking for granted, right? So if I can, do you all know piece by piece my voice, how it goes there and gets reproduced? How many know piece by piece all of that? You have kind of rough idea. Sound, oh, you know everything. Very good, smart guy. Huh?
You're belonging to telecommunications. So
Okay, but still there's a lot of mystery. You don't know the protocols, don't know where is the data packets going from here to there to there to there to, is it going on a fiber optic cable under ocean, or is it going via satellite? Just happening somewhere in internet or fibers and cloud. But what's important is that you sort of accept it, right? You sort of have an idea that I speak, a microphone picks it up, probably converts into electrical signal, then some telecommunication, somehow boom, it goes there, converts that telecommunicated signal into electrical signal to the speaker so I can hear. And with the video, you can feel the same way. My camera takes a picture, makes it digital, compress it into some packets, and then it's all digital data, whether it's video, audio, who cares? It's all the same. Goes on the other side, take out those packets of data based on some little trigger or some little tag that's that, okay, it's a video, then you recover into MP4 video format, and it comes out, and the LCD display, it shows. You see? You can work with a phone. So by the way, therefore I want you to feel that you can work with implantable devices now. You don't have to be awed or afraid. It's all pieces, right? Step by step, nerve, electrode, stimulator, chip, IC, this and that. If you stimulate a bladder empties, you do something, it blocks. It's step by step at a certain high level. Then as needed, if you're electrical engineer, go into the chip design. If you're telecommunication, go into wireless and protocol. If you're a physician or experimenter, you go into pelvic nerve and detail. So BCI sort of holds the promise of why even use voice? Now, why not just mind? Well, okay, please, that person sitting there, don't speak up about mind. I don't know what mind is. But thought, which is I want to move my arm. Do I have to say that? Do I have to convey that to my nerves, to the muscle? Or since motor cortex has a plan, why not tap into it and make it happen? So that, in a sense, is the promise of BCI. Although it all started with, as I said, ALS, this locked-in syndrome patients who are completely locked in, they couldn't communicate. It's a very small number, but that's how it works, right? I mean, Tesla, when it came out with the amazing car, the very rich people who had they wanted to show that their car could go from 0 to 100 kilometers in 3 seconds, or show off how beautiful it is. You start there, and it's now the Tesla cars are becoming very popular, at least in the US. So BCI started with altruistic medical reason of some people who are completely locked in ALS, and then it filtered to more people who have stroke and such disability, and then sort of like notion that like company like Neuroscan and all that, they started to market as a gaming device, and then that sort of bit of backlash. The Defense Department in US actually created BCI this way. So they were interested in, nowadays militaries use drones for surveillance. Can you imagine a drone that's flying around in, I don't know, Pakistan, Afghanistan, collecting all the images? Who's looking at them? I mean, who is scanning where is that guy Bin Laden or whatever, those other terrorists in that building? The data probably is there. So there was a project that what if we can review the video from the drone at high speed? Not so easy for us to do that, right? But actually something about human brain and mind is rather remarkable. Remember I told you about that waveform, that P300, surprise. So even if you're scanning at high speed, if something anomalous, you register. Ting, that P300 pops up, you freeze because there's something there. Your brain or mind has captured something more than pure image process is going to do that. And then, so there were like defense departments that way they pushed this to futuristic direction. I mean, of course, you can control the drone with your mind. It's actually one of the very popular videos out of University of Minnesota that you can control a drone to go up and left and right. It's very slow, but it's good. So BCI BMI its value, it started altruistically, it stays there because it captures your imagination. You guys go home and say, what are you doing? Well, I design brain machine interfaces. Whoa, you're a genius. Now, of course, they'll probably, you'll get also not become, it's just too smart, let her be. But generally it looks like wow, but it's not that complicated. So so BCI cannot read minds. Writing to the brain is becoming interesting to people. What does writing into the brain mean? Read the brain, write into the brain, kind of like stimulation. But when you stimulate that, does the message remain for permanently or long time? Somehow the screen, you have to tell me once in a while if it's stuck like this, okay, because I'm not looking at that. So, but this is becoming more realistic, the brain control of prosthetic arm, and there's a lot of research today is focused on it. The medical use of EEG and BCI like ALS, few other might happen, but here are the kind of interesting neuromarketing, Coke or Pepsi or Thumbs Up or whatever it is nowadays. We do the marketing decision. How do you know? Why do we like something? Why do we not like something? Brain control of gesture, right? So originally, first generation people were using mouse and joystick. Then came touchpad. Maybe now voice communication. So why not gesture? Hey, tick, click, tick. But that's not BMI, but its gesture is possible. There's a Leap Motion or those kind of companies can do wonderful gesture tracking. And then next would be just why not just think about it, right? You come, put your face, your thought, EEG picked up some words, wireless, and computer opens up. So there are all these interesting, some realistic, some futuristic notion about BCI. So someday, as I said, reverse engineering the mind, probably in a very limited manner. Really what we are doing is interpreting certain mental activity like movement. Write to the brain is really not writing into the brain specifically, because we don't, it's not like a book or it's not like a precise memory, it's very distributed neurons. But maybe by feedback you can do plasticity, so the brain can adapt. When you give feedback, it learns to accept it. So brain writes it, you don't write it, you're providing just the feedback. So we all learn, right? By every time we touch and it's something hot, next time you don't touch it because you know. So you have developed that adaptation and plasticity in the marketing and so on. So for healthy people, for now there are limited uses because it's really slow. I mean, it is intriguing, but it's a very slow way to communicate. Even the fastest of BCI might type 1 or 2 or 3 letters a second, even at that, and not even that, like 2-3 letters a minute. I mean, it's really slow and error prone and so on. But you really never know, right? I mean, look at how better the phones became, how better the computer became, some amazing algorithms, better sensor. So you keep an open mind. So people with disabilities may benefit because they have a reason, particularly like ALS locked in for huge reason, stroke and paralysis, medium reasons, healthy, low reason, just other than fun. So how is BCI constructed, right? So of course the brain computer connect to the computer and sort of that's the pure idea. And neuroprosthetics is the similarly, brain, but then you're controlling a prosthetic arm. So how is the system kind of put together? You acquire the signals either from a person or a monkey when you're doing cortical neuroscience, or a rat. People started with rat to make sure you can control the rat brain. Record signals like EEG, ECOG, or record directly from the cells. A lot of research now has gone into signal processing, so you can extract features and information. And then eventually you have to translate that into practical algorithm, which is for opening and closing prosthetic arm, or this checkerboard thing I was telling you about, P300 type, as a way to communicate text or even control wheelchair, and then you would need a feedback. So that means all this information is fed back to the person. So step by step, a lot of different signal processing methods, classification methods, a lot of research goes in this area. Command and execution, and then closed loop feedback. So how does it kind of work? So there are some regions of the brain are preferred over others. So a lot of that kind of electrodes are in sensory motor cortex, because motor imagery shows up there and it's easier to put electrodes. So that's generally been the source of action. So when you have a mental activity, whether it's typical initiation of some thought and imagination idea is probably what's called prefrontal area, right? This is the Broca speech and language. These are all pretty high level intelligent areas. Then it can go to your eye field because you want to see where you want to go. And then this is a premotor cortex, which does a lot of planning and all of that. And then there is a motor and sensory area here. And so when you imagine a movement, turns out roughly somewhat similar. By the way, you don't have to only imagine movement. You can imagine anything, calculations, emotions, as long as you force a change in brain activity in a reliable way. That is up to you, right? You need to be able to control your mind, keep it focused on the change. Otherwise, it's hard to implement. So generally, motor imagery is intuitive. Move the arm, move the prosthetic. So it's generally intuitive. But as I said, P300 is also a parallel idea. Okay, so I told you like motor cortex is rather, I mean brain is very complex, but there are all these regions, and this has to be large, right? I mean we evolved from monkeys and evolved from that, so movement, feeding, these are all big things. This is a more recent part of our brain development, because monkeys didn't need to do intelligent ideating and taking quizzes and emotions, all those kind of things. They just needed to move, feed themselves, have sex, live forever, whatever. So motor cortex is rather distributed from premotor or supplementary motor. So this is the premotor, this is the supplementary motor, a lot of little subtle complexity, a lot of overlap. Motor cortex in the sense that a lot of the signals then do go to the spinal cord, to the rest of the body. By the way, like if I want to move my finger, it's a little tiny region of the brain somewhere here, controls for the finger. There is what is called homunculus. So from finger to hand to leg to mouth is distributed everywhere. So BCI systems are a lot of signal processing. I told you, right? You're looking for change in EEG. You know, this people have used wavelet, but you can use spectrum analysis, many different ways to look for change. So, right, as soon as there is change, I can use it as a trigger. So they look for in this case they use gamma band. So there's something happened, the gamma band changed. So it becomes a very nice trigger at time 0 to move or do something. Okay, I hope you follow. So it's somebody recorded EEG, you're doing a BMI motor imagery. When you do that, you get all this is the time and these are the frequencies, and you can see that at the time of moving or decision there is a gamma band frequencies, although there are low frequencies too, but they're more spread and they're not very specific. So this could be a very nice clear trigger. So you look for power in gamma band and say, okay, open arm, close arm, all that. So there are a variety of these potentials in BCI, BMI. You know, there are event related potentials. P300 is one of them, but they are essentially evoked response. Event related synchronization. So that's kind of interesting, that when you are creating a certain type of task, the brain rhythms become synchronous. Not so much like epilepsy, not that synchronous, but there is a higher synchronicity. Another time it gets desynchronized. And what you're looking for is a change. So these are many ways to look for change: frequencies, synchrony, desynchrony, entropy, dozens of approaches, dozens and dozens of approaches to finding that change. But in a nutshell, that's what it comes down to. Person, where's the EEG cap? You do some spatial processing like where, then feature extraction from what's in there, then classification. Do I want to move left? Do I want to right? Open, close? And each one of these, what happens is when you do motor imagery, you saw that at that time, in this case, like this is called a mu band, 10 Hertz band, the power reduced. That is my trigger. So anytime I use that trigger, the arm it can go to the arm open, arm close. Of course, feedback can change everything too. So how can I do more than one task? It just seemed like here we are just doing opening and closing. How do I do more than one class? So well, I can do left motor imagery, right, left leg, right leg, tongue movement. You have to have the ability to keep your mind more quiet, silent, so that a lot of noise and clutter and shifting doesn't occur, and the message that you are imagining moving a tongue is very clear and separate in different part of the brain compared to left hand versus right hand versus foot. If you can do that, then you'll have multiple signals, and now you can do 4 or even combination 15, 16 different tasks. Impossible. We are generally up to about 3 tasks. Okay, you can read it, so let's go. But there's lots of ways to record a single electrode, whatnot. So there are many different BCI categories: non-invasive, invasive. EEG is clearly non-invasive. ECOG is certainly invasive because to put the electrode, you do need to put it in the brain. And microelectrodes for sure, because you are penetrating, you are putting electrodes in the brain. So they are all different BCI tools and techniques.
As we are moving to high resolution, it will be easier to get the various function from one human. Like we have to keep brains calm as silent.
From EEG, it's one of the pieces of it, but whether the question that somehow if I put 8, 16, 64, 256 electrode, can I find separate different regions of the brain? I'm not sure. Oh, that's different. So let's not mix it up. Don't go back. So EEG is on the scalp, very separate. Maybe you can separate 1 or 2, maximum 3 tasks. Microelectrode on the other end, every population is highly specialized, so you can separate out a lot. Very high, much higher resolution in theory.
But one question: when I am thinking for moving my hand, my microelectrode and somebody else's microelectrode location will be same.
Yeah, it's. I think that is. It's a good question whether whether the microelectrode implants are the same. Can you make it similar? And no, I think at this stage this is all very specialized. But if you look at consider pacemaker like example, now they make generic standard pacemaker and keep some programmability, and the surgeon of course treats every patient differently. So same way here, BCI will have some general principle, gamma band, synchrony, desynchrony, classification, source localization, but then each person may need customizing because certain things work better on them.
After a level, a little customization will be required.
Well, I mean, it would seem so, but as time passes, we find some ubiquitous or common principles that don't require, because EEG is EEG. Remember, you saw the frequency bands, they don't change. Spike activity is what it is. Of course, everybody's message is different, but an underlying way to analyze spike activity might be common. So keep as much as possible common, and then few things can be made programmable. But implantation and all that is probably always going to be customized, right? Every brain, these wonderful pictures I show are very gross, very general. They vary a lot.
So question, like in brain, when customization is done during surgery, that is done by when implanting microelectrodes. They are done by surgeons or engineers during surgery.
Well, it's like a teamwork where surgeons don't know anything about microelectrode and this and that, but they are the ones who are going to implant.
Yes.
So what will happen is that some engineer may have done the MEMS electrode design, others may have assembled the whole system or acquisition and so on, or maybe some company has put it together to that point. But then surgeon might do the pre-surgical planning, they might do MRI scan to know where the motor cortex is, so they through pre-surgical planning they know where to put the electrodes. And then electrode implant itself, they will do that. But how do they learn? So the company that developed the electrode will develop a surgical procedure, and they would test it on rat first and then monkeys, and then surgeon probably would come there for training to know how to do that. But once they've done it 1 or 2 or 3 times on human, because human is not a rat, they will become more proficient. And so in these kind of systems, they work hand in hand with each other. So at some point, developing the technology developers work together with clinicians and surgeons. And in an ideal world, it would be a more complete team.
Yes.
Yeah. Okay, so you see that there is a BCI invasive, non-invasive, variety of different ways to do that. So EEG clearly has some advantage of being non-invasive, and here in India, if you're sitting at IIT, you do EEG based BCI. Why EEG is not as desirable is if neurons are here, you're just picking up a gross signal. So it's very safe for very coarse resolution. Microelectrode, when they implant it, is less safe because there is invasive implant infection. Electrode will go and tear and damage a brain a little bit. But look at the resolution, it's very specific. You can go to a very specific area of the brain. So these systems have all pluses and minuses. So I mean, I was expecting our guest speaker to be here today, but I haven't seen them, so I'll keep going, okay, because I prepared only up to this point. So let's go back to EEG. Sorry? Oh, you want to take a break? This is music to my ear. I mean, do you think I like non-stop talk? Okay, right, so we'll pick up honestly BCI today, take a break, sounds good. Please learn to speak up. okay, because and give me feedback and all of that. Okay, excellent. Take a break, maybe when they come. All right. They may be. I don't know. Nobody has come and told us anything, so I just don't know. Usually I just sit here and keep talking. So go find out. If there's something, let me know.
Little bit overburdened, overloaded like? No, not so much. Anyway, so today evening we listen to another interesting talk from Dr. K. Ramchandran. Right? So Dr. K. Ramchandran is the director of Defense Institute of Psychological Research Lab. It is popularly called DIPR lab, DIPR lab. Okay, it is in Delhi. So Dr. Ramchandran in fact is an expert in the field of experimental and human engineering, aviation psychology and environmental psychology. In fact, he is famous for the invention of computerized pilot selection system. It is new of its kind in the history of defense. Nowhere in the globe has followed this kind of concept. So it is based on psychology basically. So in fact he is a psychologist, he is a Madras alumnus and he leading DIPR lab since 2013 and he has many key ideas that he has many vision also to make the defense system is a unique and then very fruitful for our country. Our country India is geographically a little bit complex, you know, and also has a very large defense base. And managing such a large defense system, it depends on in many ways the responsibility of DIPR lab. So it is his responsibility and he is carrying out it effectively since 2013. So it is our opportunity to listen to his recent activities, the ideas and some brainstorming concept also. Okay, so may I request Mr. Ramchandran to take the dais and start the.
Thank you, Professor Debasis. Very good evening to all of you. And the future of India, I am a call. First of all, like being a student of psychology, even I am a student, I would like to tell you very frankly, still I am learning. When I used to be a student, to begin with, my intention is when I was doing my graduation, just to get some 50-40 marks to pass, get a pass mark, that's it, right. When I moved to my post graduation, then there was a challenge. So obviously you have to compete with your colleagues and obviously you have to prove your worth. The expectation from the process were different. So obviously I started learning. Whatever book I read, again I read it, and then I joined my the present institute way back 30 years back, and there was a greater challenge for me. That was the time I realized that when I was doing my doctoral work and things like that, it's going to affect only me. It is not going to affect anybody. Whether I get PhD or not, it's only going to affect me. No, it's not going to affect anybody. But when we went to the field, when we saw the people, that time we realized that like no, whatever I have read, now again I read the same book, probably I could comprehend maybe 10 to 15% of what the author would have thought about it while writing the book chapter. So the total perspective changed from what I was a student, I read the book, and now when I read the book, it's totally different. So it's based on the perception, the cognition, all these aspects play a role. The environment teaches you a lot, constant feedback which is coming to you. Ultimately, you have to respond in an appropriate manner, for which the maximum thing is use your brain, right? Use your cognitive functions effectively. So what is that all about? Generally, all of you are expert in your respective domains. You have been interested in understanding human mind and how it works, things like that. But before we get into it, I've got a lot of expectations from the younger researchers. I belong to DRDO. One such laboratory is called psychological research. DRDO means everybody will think about like missiles, tanks, aircrafts, the weapon system and things like that. Yes, there are majority of the labs are working. Out of 52 labs, almost about 42 labs are concentrating, 43 labs are concentrating the weapon system. But there are a small group of lab called life sciences cluster. There are 9 labs which are focusing on the men who is going to operate those sophisticated instruments. We are interested in understanding them. We have got 2 groups in life sciences. One is called biomedical group, another one is called agro-based group. The biomedical group, our institute DIPR, we focuses mainly on selecting the right man for the right job. We select with that, and subsequently placing them for the right job. Placing the right man is an absolute necessity. So, we do that, and subsequently we check their psychological well-being in all those areas. Another lab, which is Defense Unit of Physiology Allied Sciences, takes care of all those physiological monitoring. When a person is put into extreme vagaries, what are those physiological changes which are going to take place? How it is going to affect his behavior? Both physiological and biochemical aspects have been studied in depth by them. Again, we have got another lab, Institute of Nuclear Medicine and Allied Sciences, which concentrate on the radiological, particularly the nuclear and radiological effects on human being, both physiologically as well as psychologically, how it is going to affect. That is being studied thoroughly. Then we have got one more lab which takes care of the chemical and the biological issues, which is at Gwalior, Defense Lab at Gwalior, which takes care of the chemical effect on the masses. You all know that malaria or any kind of a virus comes, it creates mass panic. So, how to contain that one, and they try to work on that. We have got another laboratory which totally equipped for defense biomedical engineering laboratory, which takes care of any kind of now you want to see that you are working for the men who is sitting in a border area. If he has a problem, so what kind of a medical help could be reached over there, or you put him into extreme environmental condition, what kind of a physiological and the comfort you should give in order to make him work very effectively. For example, you want to send somebody 100-meter depth of a ship, in a seashore, when the submarine goes down, you want to get it repaired, you have to send him. The human capabilities are limited, but you have to equip them with additional things, so that when he goes in such a pressurized chamber, his cognitive function is effectively, he is able to handle the job effectively or not. So, like that takes care of. And we have got another 3 or 4 laboratories which are located in different parts of the country. One is at Leh, takes care of the agro-based animal products for the fresh food items for the soldiers. We have got Haldwani, we have got a lab that takes care of another aspect. We have got in Tejpur, we have got a lab, basically the entomological and as well as the waterborne disease that has been taken care of. We have got food research laboratory, where it takes care of the food additional nutritional requirement of the people. These are all the labs which takes care of the men behind the weapon. Of course, there is a specialized lab, we call it as Center for Artificial Intelligence and Robotics at Bangalore, which takes care of all, majority of you are engineers, some of you are doctors. So, it is a combined group. So, I am trying to give you an input about it. They try to take care of those aspects where what kind of an artificial intelligence or the machine learning or deep learning algorithms are being developed in order to secure our system. Information war is one of the most important things which is threatening all over the globe. So, they work on it, how human think, how he act, how to counter that one. If any cyber attack, how we are going to counter that one. You have to think ahead of him. So, ultimately you have to make machines think in that way and try to identify, because the information is coming enormously on you. So, they have to understand that one. So, these are the kind of a background on which we have come. We have got various other laboratories also working. For example, if any kind of a nuclear disaster which is taking place or nuclear Bhopal incident kind of a thing occurs, automatically you have to go and rescue people. You have to develop sensors which are going to help you out and identify what is the kind of the harm it is going to create on human being. Before that you can sense it and you can evacuate people. So, like that many areas we can work. Suppose we want to send a recce vehicle to evacuate. There is a bomb which is planted in some location, you have to send them. Today various techniques have been evolved every day and out throughout the world. As we see such a kind of a technologies are coming, automatically human brain has to work ahead of it to counter those kind of an anti-national forces. We know that cognitive psychology it's almost a century old. It started way back, initially with a structuralism. In late 1880s it started. Then real boom came in 90s, first time the computer intelligence and the machine learning, the first paper. In 1950s it exponentially grown, and even today we are still growing. There are a lot of issues, lot of things which we are not able to understand, how we feel, how we think, how we act. Because how we feel, we can create many things, because today's by using by understanding the cognitive psychology or the learning process and the memory, all this aspect. But first of all we have to understand the basics. You are all expert in your own respective domains, but there are many areas which if you are able to understand the basics of human behavior, then you are able to apply it very effectively, convert them into your own areas and use it for the well-being of the humanity. For that matter, you have to understand this thing. Cognitive psychology, what is it? I am just going to touch upon, because though yesterday Professor Mandal has talked something about it, I am going to tell something basic and relevant areas wherever it comes. I will give you the challenges what we faced when we were working towards this particular aspect of cognitive psychology, and especially in the cognitive science area. What is cognitive psychology? If I try to ask, like no, before that, you all can see that what is happening. Is it rotates? Okay. What is happening in your mind? Can you tell me? It is a simple thing. It is not rotating. How you perceive, how you process, how you interpret it, what you have learned in the past, it makes you not to accept that as a reality. Various illusions, everyday life, what we see, what we interpret is all depending on our growth pattern. So, in order to understand all these things, you have to understand how it works, what is the basis of it. If you are able to understand the basis, you are able to devise a machine which can give you answer for that. You can come out with the human agonies could be easily alleviated. Let us go to the next, if you try to see again. Is the lines are same? Again illusion. It's called Muller-Lyer illusion. So, there are very many things. Suppose if I say that, like if I show a finger like this, if I ask you what is this, every one of us perceive, interpret in our own way. There are so many aspects, because whatever we have learned from the past, from the society, it is already there in the perceptual set as a set in our brain. It is stored in our memory, and we try to reproduce it with a logically, rationally acceptable way. We try to project it. So, for that one has to understand. As I said that, like cognitive psychology evolved long back. Initially basic from a branch of psychology it came out, and then later on it became a cognitive science area, because cognitive psychology, from psychology it came cognitive psychology, later on it became cognitive science. Cognitive science influences very many disciplines. If you ask me that, all the disciplines are contributing for the cognitive science, your computer science, your engineering disciplines from electronics or electrical, all those aspects, plus physiology, sociology, philosophy, anthropology, medicine, all these disciplines are trying to find an answer to understand what is human mind, how it operates, how he perceives, how he interprets, how he processes the information, all these aspects are done. But it started by psychology, initially it started as a structuralism, then becomes like now there are so many theories evolved after that, like the functionalism, the psychoanalysis, gestalt psychology. After that came the era of the cognitive psychology, and still we are not able to answer all the questions. We are able to create robot, thinking robot, serving robot. Very recently you all might have read, near Chennai there was a restaurant where the robot comes and serves whatever you want. How you make them think? Can it feel? Can it express emotion? Maybe broader emotions it can express. Can it express emotions like us? So many things are unanswered. So, for that we have to understand the basics of psychology. Psychology is not a great, no, it is a difficult subject or things like that. It is like a novel reading. If you are able to observe somebody, you are able to analyze, even you yourself sit and analyze your own behavior. What happened to me when I start looking at it? Probably you are able to come out with an answer to that. So, that is why I just try to give you a simple example and definitions, or what to understand what is cognition, what does it comprises of cognition. If you try to see, the cognition comprises of all these subjects. Starting from biological side, you can analyze cognition, cultural cognition, social cognition, genetic aspect you can explain, psychologically you can explain, etiologically, ecologically, developmental side, chemical side. All these aspects contributes to understand the cognitive patterns. What is cognition? You can understand it. What are the major issues if we try to understand? Why we have to understand? We have to seek answer for these questions. Then probably we are able to understand what is cognitive psychology. How the knowledge is represented. How does individual acquire new knowledge? How does visual system organizes the sensory experiences into meaningful objects and events? The first picture I showed you. How you are able to arrive at a meaningful solution to that. How does that memory work? Is it like CPU? There is a big CPU here. How does it? What is the, how much terabyte, or you cannot say. Such a huge system. How does the brain learn the things and acquire those knowledge? What makes an experience conscious, and what is the basis of unique cognitive capacities of a human brain retrieves to that of other similar spaces around. There are many animals also imitate, like now you can teach them, they will do that. Lot of WhatsApp, probably you all will see that. Very recently somebody did an experiment with a crow, right. He put a cage, and then obviously like now it start picking a small stick, it takes the pulses out, goes and drops it and have his food. Both Skinner or as well as Pavlovian conditioning kind of a thing, that which they try to prove it again, how even animals could learn. Put in a circumstances, probably they could also acquire knowledge. So, we have to get answer for all those things. If we are able to address all those issues, we can find out. As I said, that psychology, basically the science that deals with the behavior, both cognition, emotion and the action. But cognitive psychology, it investigates the representation of processing of information by animals and human beings. Why we say animals? We are primates, evolved from that. So, if we are able to, majority of the experiment we conducted on animals, subsequently we later on represented to human beings. And information processing, which is depending on internal representation, especially the sensory input. We get lot of sensory input, both visual, auditory, kinesthetic. We have got all these kind of a sensory input which is coming. How that is perceived, how that is synthesized, how it is processed, and what kind of a meaning or representation we are giving out of it. If we are able to understand that, definitely we will be able to do that one. That is why we call it as mental representation undergo the transformation that is of a stored memory. Every time we learn something, we modify that storage capacity and we try to do it. That is how the cognitive science is acting on it. There are cognitive processes in daily life. We all use this terminology very quite often we use this. We say that you please pay attention to me, right. What does it mean? The concept of attention, that is how we filter or select important information from the environment, that we call it as attention. We collect the information from the environment and that we say attention. Sometimes we say I do not know. What do we say? That is the knowledge which we possess. If we do not have that knowledge, prior knowledge with us, we tend to say that I do not know. So, this is a store of general information and algorithm in performing certain tasks. That is what is the knowledge. Then comes memory, because I do not remember. What happened? You are not memorized those aspects effectively in your mind. That concept is called memory, a process of storing, retrieving and working with the information. Again, another aspect is I cannot decide. I have to take a decision. We say that I can't decide, which means decision making. That is basically set up higher level process that work together and allow us to function in a day to day way. So, all these aspects, like now if we are trying to analyze one by one, we get to know the answer. For each one, lot of theories which as experiment which were conducted, based on that people have given varied explanations to that. From simple to complex level of information processing, they have come out. What are those things? What are the roots that, like if we try to understand that, like now? Basically a philosophy of mind, that is the subject matter that deals with the structure of mind and relationship of mind and body. Many a times we have got. Suppose if somebody comes and asks you, like now, where is your conscious? We call it as where is conscious? We cannot say where it is. Generally say that, like no, we say that it is here, but where it is can we locate and tell. So, that is why it is philosophy of mind, how the mind and body is related. That is what is talks about in the philosophical way. In neuroscience, generally you all are expert, a science that establishes link between brain functions and behavior. They say that like this particular aspect is responsible for your motor response, this is for your visual area, this is for your speech area, all these aspects. So, neuroscience. Computational intelligence is nothing but the subject matter that aims in understanding the intelligent agent in computational time. How we compute those information in a binary manner and try to interpret it. Whatever knowledge we have got, we try to make it in a programming way and we feed it into the computer responds to that. It does not think on its own. Whatever you know, you have written that one and you gave it to the machine, and later on the machine start interpreting. Only thing here is the speed, reaction time is going to vary between the machine and the man. That is what is computational. When it comes to language, again language, it is the main tool through which our thoughts are expressed and modes of reasoning become interest. How we express the language is because there are many different kind of language, from sign language to spoken language, even spoken language from English to any other language. All of the things are learned and we try to express our own ideas. So, that is also equally important. Another thing is culture. That is, a cognitive account assumes that some trends in culture result from universal properties of human mind. There are cultural, because there are in certain culture there is nothing called past tense which is there. They speak present and the future only. They do not have past tense kind of a thing. Every cultural cognition is another important thing. In generally, in Indian culture, if you try to see that in any kind of an auspicious occasion, people would not like to wear black clothes or black dress. So, this is again, this is a society which has influenced you and try to you learn all those aspects within you. That is how it comes as a cognitive. So, when you must understand that the history of the human science and cognitive psychology evolved not from now. It has early in philosophical roots it has got. Socrates, he talks about origins of knowledge. They talked about cognition at that point of time itself. Plato, he talks about brain as the seat of mental process. He says that like it is the main component of making every activity by a human being. Aristotle talks about knowledge and memory. both these aspects, like describes mental representation of knowledge, that is mind body dualism, he has talked about it. All these things has got a strong root in your own ancient time itself. People have thought about it, like how a human being behaves, how he thinks, what kind of a knowledge he possesses, how he represents that knowledge and give it to other people. All these aspects were there in psychology. Again, coming to Piaget, theory of cognitive development, thought, language and intelligence of children and adults. They have gone through a series of things. See, we have got in psychology, in many a time we used to talk about how the proper, there are certain things which still we find it difficult to find an answer, because majority of the physicians over here, probably you will be able to give a realistic estimate of it. When the Piaget, when he gives the developmental stages of the child, for example, he call it as there are certain is oral, anal, phallic, latency and genital kind of stages he has given. Each age the individual is able to remember the things and reproduce it in the later stages. Particularly if you find that many of us, initial 2 years of our life, when you are up to age 2, what are the activities we have done? Are we able to remember? Why is it so? After that you are able to remember. When you go to the school, you ask who is your nursery teacher, even today you are in a position to tell. Why? What is the reason behind it? Have you ever analyzed that one? Again it comes that, like he talks about fixation stages in Piaget, when oral fixation, he talks about it. For example, the child is not mother fed, breastfed. The satisfaction is not fully achieved. The child tend to develop a habit in the later stages. Probably he studied his own children, all his 4 children he studied, and he recorded each and everything, and after that he wrote Piaget. When he talked about, later on the child developed thumb sucking, probably at the age of then chewing gum, later stage smoking. The oral satisfaction is fixated at that, which means that gene or somewhere it has been stored in the individual, and which is exhibited as a behavior at the later stages. Imagine, which means where it is stored. That is what we have to find out exactly, that where those kind of an informations are stored. Early childhood development, wherever the fixation occurs, that fixation later on comes as a behavior in an individual. So, can machine do that kind of a thing? Suppose if we talk about, we want to make a robot, thinking robot like us, can we make it? Probably if we start exploring, if we start understanding all those small issues, definitely we are able to do it. I will give you another example. During World War II, our own soldiers, like their own soldiers, because of the battle fatigue or whatever it is, like they start, because somebody coming from other side, they start killing their own people. It was a major issue during World War II. That was the time the cognitive psychology put its root. So, basically you have to understand the human performance. There are so many challenges at that point of time. These are some of the things. They wanted to study cognition to understand the human performance, attention and perception, because actually they are not able to differentiate between the enemy and them. That is how it started. Under stress, how your brain works. The channel capacity, you are not able to process so many inputs which are coming simultaneously. Probably there is a channel problem, wiring problem occurred, because there are two, both the main and the current, both the power supply went in the same line. That could be one of the reasons. So, your attention get distorted, your perception get distorted automatically. Again they had problem with the soldiers to use radio and radar. The blinks, because they are getting peep sound which is coming, they are not able to distinguish between those sounds. And the sonar, again there are issues, like there are blinks, false alarms used to come. It triggers anxiety in them, and ultimately their behavior is getting affected. So, these are the aspects which triggered for the people to go in depth and try to take it into applied level. Signal detection came, signal detection theory. Again, mainly particularly beeps in the radar and sonar. The sound, for example, like if you are going to give a sound, you know that how much millisecond it takes, and you are supposed to distinguish between friend or foe by peep sound. You all might have read very recently there was a, the submarine movie which came by the people, they try to identify. So, how the human mind is processing whether the pip is coming from my soldier side or from enemy submarine side. Now, you have to use it. It is life and death problem. So, he has to be alert and as well as try to come up. So, automatically that is come. So, that is how when people find it difficult, why some people are able to process the information very effectively, some of them are not able to process the information effectively. There came the information processing theories. They came. They tried to address the abstract method for analyzing and the information processing. They tried to start with that and subsequently they carried forward. So, any person who want to work into these areas, any whether it is a human side or from man-machine side or you want to produce something, you have to understand the basics of cognitive processes, for which you must read something about all these kind of a theoretical aspect and how the contribution, which is because every field is contributing. As I said that all the fields are contributing, human performance, abstract way to analyze processing of information, development of psychological tool. See, I want to identify a person who is best suited. Today, for example, air traffic controller. Can imagine air traffic controller has to do a multitasking kind of a thing. There are so many information which is coming on board, and automatically he has to, particularly during nowadays, if you go to the Republic Day parade time, you see that like when the parade occurs, the formation of flights, different kind of an aircraft with a different kind of a speed, they take off and they plan it very methodically. When they have to come and land, one after another, you will see that there are 5 aircrafts are doing aerobatics. After that, they have to go back and land in the same airfield, that is same runway. Imagine with high speed performance, they have to land and you have to coordinate the kind of a stress and the information processing which is required for an air traffic controller, how strenuous it is going to be. Imagine. So many inputs are coming. He has got visual, radar input comes, the auditory input comes, and you know one thing, sometimes this signal like jams. Your visual and auditory, it might jam. I will give you an example for that. For example, like when, see, many a time people talk about it, you all must have heard about it. Because of automation, it brings complacency in us. There are pioneering work was done by very many people in this area. We think that like now we are trying to help human being to automate it. How many of us are able to remember 10 mobile numbers without looking at the mobile? Earlier people used to ask, no, they will give you about 20 or 30 phone numbers just like that. Today we look for, immediately we go, you want a number, I will check it. Even your own spouse number you have to check sometime, you will forget. Because this has produced complacency. I will give you an example for that. When A320 aircraft, when it was designed, it was called as an engineering marvel, okay, all over the world. A320, when engineering marvel, it was described as an engineering marvel. The first accident occurred in India, that too in Bangalore. What happened? The autopilot was overruled by the pilot. He made a false perception, he took a wrong decision, he overruled the autopilot, landed before the airport, all the people died. Imagine what is the cost of automation. So, the information overload also affects the people. At the same time, the channel, I was talking about the channel problem, both auditory and visual channel. I will give you another example. When a pilot was flying an aircraft, the aircraft had a problem, the air traffic controller calling him eject, eject, okay, he keep on telling him eject, eject, eject. This person is not ejecting the aircraft, he is acknowledging it by in his joystick, he is acknowledging what he speaks, he is acknowledging, yes, I have heard you, I have heard you, I have heard you, but never ejected. He went with an aircraft, he died. Now, what do we call it? People say that tunneling of vision. Is it an information overload? Or he doesn't, he acknowledged it, but whether he really heard what he was telling, or what he was gluing into cockpit to retrieve. What made him to do that? He is no more. Now, if we do an analysis, we do not know what is. We may do all kind of an interpretation. Possibly this could be the one, that could be the one. So, human brain, how much capability an individual can process the information in a simultaneous way, parallel processing or a serial processing. In order to understand that, we have to understand all these theoretical aspects of it. And similarly, that is why we say that we have to take help from all human performance, artificial intelligence, where like all the computer people, you are in a position to tell computer as an information processor, but is it, can it outbeat human being? If it has to outbeat, what kind of an additional thing you have to work on it. Tools to study cognition, again, what kind of a tools you have to use to understand the cognitive processes, each and everything. Each experiment has got a problem. I will tell you one more small example. We want to study the mental workload of a pilot. We try to establish. All over the world, they do experiment in an in-house, right? But in-house, when you do an experiment, the natural process which are going to occur in a human being is not going to occur. Because I know that outside there is somebody, he will rescue me. Okay? So, my natural reaction will not come. When you put me in a natural condition, your experimental protocol cannot be controlled. When we want to study this thing, what we did was, we tried to integrate all the process, particularly as we were talking about the channel, sensory inputs are coming, you have got auditory inputs which are coming, and how much mental load a person is capable of handling. See, whenever any exigency occurs, you have to have some residual capacity, then only you can immediately attend to that. Now, how to understand how much is the mental capability of each and every individual? How do we say that? Okay, I say that like no, this has got maximum I can fill out about like okay 500 ml. Beyond 500 ml I cannot fill it. Am I right? It will spill over. Now, suppose I am thirsty, I will have this much, but at least I should keep some residual so that in case of emergency I should have it. Similarly, I want to quantify all of us. All of us have got the same size of the brain, same size of an education. When the teacher comes and teaches, he teaches to everybody the same. Why some of them are extraordinarily doing well, some of them are not able to do? There are individual differences. Now, how do we address that one? Now, to understand the mental workload, what we did, we also thought that okay, we will design something, we will do it. What we did was, we did a primary task. Primary task is okay, he has to drive his car from Kharagpur to Calcutta, he will go by 60 km speed, beyond that he will not go. This is a primary task. Now, secondary task is, whenever he is driving, his other resources are empty. So, I will tell him that other resources, you do some mathematical calculation or some kind of a study. If he is able to drive properly and as well as do some other activity, which means he has got spare mental capacity. Now, while doing that, for example, while driving, listening to music, all of us listen and we drive also. All of a sudden, if somebody jumps in, what happens? Will you listen music and do it? Your channel get arrested, your resources are stopped and you try to attend, full attention is going towards only saving the individual or yourself, right? It occurs. Many times we are in the habit of, that is why they say that you do not talk on mobile phone and drive also. Am I right? Why is it? Because you are not able to, the time sharing, multitasking in the brain signal does not occur. So, you have to understand how the process is going to be. So, we try to do that, not with these two things. Okay, these two are okay, you can do as a psychologist, you can do, but I want to see exactly which particular part of a brain get activated. When he is performing a particular task, what kind of, if I create some kind of an emergency, which particular portion, is it your left hemisphere or right hemisphere get activated? What kind of an error which is coming? That is one. Second thing is that I want to see that how much cerebral, I mean the oxygen has been pumped through your blood to the brain, because your neurons or all those aspects, if it has to get activated, it needs some kind of a chemical too. Through oxygen it gets transmitted. So, obviously, how much blood volume is pumped to your brain. We want to see that, like, no, that is another aspect. Then your saccadic eye movement, what are the aspects which you are scanning? When such a kind of an emergency comes, did you scan everything? You try to see whether fuel is there, whether my brake oil is leaking, all those aspects when you try to do it. When you take the subjective response also. After that, you tend to analyze that, which point of time the individual, you take them. First initially you do a normal duty, you start bringing the complexity one after another and try to assess his variability from heart rate to your physiological or your all the ECG signal as well as your other aspects, and then try to corroborate. Then objectively you can come out and say that yes, this individual is capable of handling this much of information in these kind of a scenarios can come out. I will give you another practical difficulties, that is, for example, when individuals are posted in glacier areas, high altitude areas, it is a snow mound area where the individual is sitting there, look up, it is snow, white. The place, entire place is snow, white. The shape changes every day because of the snowfall, every day it changes. Imagine the individual does not have any cues, he does not even see a small stone or any leaf or for that matter any sound except some firing sound, nothing. In that he has to be vigilant. How is it possible? We seek novelty. We sit in a class, maybe after 1 hour we feel that like no, we do not want to listen. After 20 minutes the span, attention span goes off. How to sustain attention? How to bring that novelty in them? You can develop some devices to bring it. How best we could do it? As I said that like no, when you want to put anything, there are basic parameters. You want to assess the mental load of individual, there are basic parameters. It should be sensitive. The equipment which uses has to be very sensitive to make those minor changes which are going to occur in your brain activity. So sensitive it should be. It should diagnose exactly what is happening. It should give a diagnosticity, sensitivity, diagnosticity. Third one is intrusion. It should not be intrusive at all. For example, first time I am wearing the bifocal glass. Initially it took almost 1 week for me to really adjust myself. I have to learn. First time you wear a goggle, it takes time for you to learn. Again, that is also a cognitive process. Whatever you have learned, you have to unlearn and relearn certain things. It takes time. So what kind of a memory, where it goes and uses the eraser to erase and write the new ones in it, which is the part of the brain which gets erased and rewritten. So all these aspects are important for us to understand. We have seen people, they go, they are staying there. When you go to higher altitude, probably you all must be aware about it. When you go to higher altitude, the oxygen is very less. So now there is a question. There is a conference which was going on about high altitude medicine, international conference on high altitude medicine, where a lot of people talked about there is a memory problem, short term memory, long term memory, all these issues which are talked about it. But I can tell you one thing, any person who is going beyond a particular height because of lack of oxygen in the environment, definitely there are certain kind of a variation in his perception, in his sensation, all those things could occur. I do not have an answer. Now I want to find out exactly, is it due to, first of all, people say that he has seen me, but he says that I have not seen you. I am looking at you, but I say that I have not seen you. How is it possible? The person is not able to remember his own son's name. The person is not able to remember his own postal address. How is it possible? His own permanent address, he is not able to remember. Few minutes back he has seen the person and he says that I haven't, no sir, I haven't met him. Just 1 minute before, he just talks inside the room. When he comes out, I ask him whom we were talking. He is not able to remember the name of an individual. So what is happening in memory? Is it due to lack of oxygen, or is it lack of perception, or is it registration there is a problem, or processing may problem, or in the outcome may problem? We do not have answer. This is what is important for us to really go in depth to understand the human behavior and try to come out, for which all these subjects will really facilitate us to design a test. I designed a small experiment when we were developing tests for selecting pilot, those days piston engine aircraft used to be there. Piston engine aircraft means like that old Mahindra van, probably I do not know whether you all have seen or not. There the driver always he has to do like this in order to take the vehicle straight. The old Tata trucks also, we have to do like this and all. Today you have got power steering, with your finger you can rotate it, it will make a circle, right. So those days piston engine aircraft used to be there, the number of aircraft are very less, right. It used to be fly very slowly, and it used to have a radio knob kind of a dials to adjust and all, and you can physically see and fly, not a problem. Number of aircraft also less, the airspace is same. But today the aircrafts are in max speed, which you all know. And in order to avoid the enemy radar, they have to fly low and fly low in a high speed. During that time they have to process what is the thing, whether it is an enemy tank or your tank, you have to see that one. It could be possible because the weapons are internationally available. Probably you want to have your neighbor will also have T90 tank, you also will have T90 tank only. Now how do you know that which one is mine, which one is enemies? You don't know. So you get lot of information which is pumping in front of you. Now how you take a right kind of a call and take a decision. So this is one of the aspects. At the same time he has to memorize also and come back. So I thought I will design a memory test to check, conventional memory tests which are available. Probably you all will know about like now sensory input, visual sensory process. When we try to do it, if I give 2 digit, you are able to remember it and tell me immediately. If I present 3 digit, you will remember, 4 digit you will remember, but human capabilities are limited to maximum 7 digit. You all might have read the article, famous article, magic number 7 plus or minus 2. The human brain is capable of processing 7 digits, up to 7 digits easily. There are few people who may go beyond that. There are various methods to process also. We have been taught, like in your computational sciences, you all must be using all those algorithms to compute it. Because there are like now we try to take it, like for example, if I give 6 numbers, I try to relate it in different way. I take it in a 4 digits in one slot, second digit in another, second 4 in another digit, like that I process, I can remember also. So during that time when we tested, when I give 6 digit nonsense syllable, that is, that doesn't have any meaning, people are able to produce it. I gave a presentation time of maximum about like 100 milliseconds I just displayed, and immediately after that like I displayed another string and I asked them to answer. They were able to produce it, with all the people are able to produce that particular age group. What I did, then how to make it complex, because any selection tool has to discriminate and differentiate between one person and another person. Like in a classroom, everybody will not get first rank, only few, one may get and second, third, like that. So again in selection process I have to think in that direction. What I did, I gave a string, I presented a string with a different number incorporated in one number, I changed in that string. I asked them to tell me which was the one which you couldn't see in the previous one is present here. To make it more complex. So your cognitive process will go further. Similarly, Stroop test, we try to use it, not conventional Stroop test. You give a color, for example, red is written in a green, RED is written in a green. Now what I did, I want to see that how the fluctuation of attention and the information processing is fluctuated and how effectively the individual is processing. So like that we have to design experiment. So that's why I call it as like tools to study cognition, how you have to think in different ways to analyze the behavior so that you are able to measure them effectively. If you are able to measure them, you can prove it that yes, this is how the human brain is working, this is how the processes are taking place. You can do that one. Emphasis on complex mental processing and decision making and reasoning, again that is also being done. Linguistic and verbal learning, questioning about the acquisition of knowledge and its complexity. Everybody, when you come initially, it looks everything is Greek and Latin, right? After some time you are able to pick up the language. In fact, like as earlier the stage, you are able to comprehend as many languages as possible. But when you grow older, probably you find it difficult to acquire the that particular proficiency in the language proficiency, it takes time. Again, there are ways and methods which are available to train our brain to acquire the new languages very effectively. It is feasible. If somebody comes and shows you the letter of Chinese and somebody shows the Japanese one, for you and me it may look similar, right? It looks graphics. For that matter, if somebody comes and goes to any of the South Indian languages, somebody will say that it is all jilebi, jilebi. You see Malayalam and Kannada and things like Telugu and all, it looks jilebi, jilebi. Somebody will say that it looks jilebi, right? So it is again how the patterns are being recognized. You have got full topic about pattern recognition, right? Am I right? So now you have how the brain is processing those inputs. What are the steps in processing? That you have to understand it, by which you are able to do it. Similarly, philosophy, age-old questions about knowledge and memory, we have to understand. And behaviorism, as I said, that behaviorists say that everything is learned behavior, but there are certain things. That's why we say that if everything is learned, there are many things which come out. That's why the basic questions in cognitive process, that talks about acquired and interpreted, how the information is acquired. What is the channel in which? Is it visual, kinesthetic? Again, you will see the response patterns are different. I'll show you another example. For example, like there is a red light. Whenever there is a red light, you press it. Okay. Whenever there is a red light, you are supposed to press it. You do an experiment, a simple experiment. It will give you a lot of understanding about human cognition. When I see a red light, I pressed it. Now, so much process. Is it reaction time? How many of you think this is a reaction time? It is response time. It is not reaction time. What happens is, once you perceive, there are so many signals which are coming. You process it. It goes, everything goes inside. It is perceived, sensing, perceiving. After perception, what happens is, there are processes which are taking place. There are so many things in your back of your cortex, probably you are able to say that whether it is lead or amber or whatever it is, processed. Then the decision has been taken. The decision has already been taken. After that, it is an motor time. So your reaction time finishes here. Once you took a decision, it is reaction time is done. Then your response time. Here the signal is passed. Through your right hand you go, you press the button. Again it is different. The motor response time is also added to that. Now suppose, think it other way. Whenever there is a red light, you release it. Response is same, but your reaction time is going to vary. Same thing, you ask him to do it in a left hand. Definitely it is going to vary. Suppose if you happen to be a right hand person, it will take time, further delay will occur. The same thing you give it to food, because the neural activity, it transfers and it goes, and when it gets executed, the timings vary. That is why whenever you want to study any kind of a human behavior, you have to control very many parameters in it. I told you when I was talking about the particular sensitivity, diagnosticity and intrusiveness. Intrusiveness is when you put anything, I feel so awkward. It distracts my attention. Your sensation, everything gets distracted. So you have to minimize the effect which is going to create on putting some kind of a lid. Can you come out with a thing that probably it is like now I am wearing a watch, it gives me all my parameters. Generally every one of us wear watches. Probably I put a small patch kind of a thing, it is not irritating or it does not look like, it looks like my skin only. Probably I pick up all the signals. Non-invasive. The operator should feel that I am doing a natural way of doing the thing. For example, I wanted a pilot to fly. During that time, all your ECG probes and wires, if it is hanging, that fellow will feel uncomfortable. First of all, I will have an anxiety. Isme current to nahi aayega, right? It is a human nature. Probably I had, when I was a child, I had an electric shock. That was there in the back of my mind. So when you put an electrode, I feel that now current is going to come on me, right? So that is going to affect my behavior. So that is why your mind processes so many information. You can't imagine everybody's mental representation everybody's experience, you cannot store it, but the broadly we can understand it. That is why human brain is such a complex system. In order to understand the human brain and its behavior, we have to understand first of all these kind of processes. Similarly, I talked about how it is stored and modified. I told you some time back how to erase it and then rewrite it. Is it really going to get erased? Amnesia. Many of the physicians could answer. What is retrograde amnesia and anterograde amnesia? Many people, they have a problem. I will show you some cases. And used to manipulate and to predict. Many of you might have heard about the great, Professor V.S. Ramchandran's talk about phantom limb. There he answers many things. Why I am saying is simple things probably you can talk about it. And used to manipulate and to predict, used to take decision and used to communicate. How to communicate? Both verbal, non-verbal, very many ways we communicate. How is it? Is it going to happen in any of the machines you are going to simulate? Does it going to do that one? There are people, phantom limb is that communication. Limb is not there, he is communicating. There are people I have seen that, like now in Kargil episode, when I went and I interviewed them, you won't believe there were that trauma which was still in there, the flashbacks are there even today. Not only that war trauma, I can tell you about a lot of victims, rape victims or the flood affected. You go and ask them, you won't believe, just you go and touch, like if the cloud formation, in Orissa we came, just the cloud formation created panic in the child, start sweating. Because they were born and brought up in the seashore, they lived there. Every day they watch, enjoy, they play in the beach, but after that incident, just simple few cloud formation, the children start sweating. Imagine what kind of trauma is there in his mind. Can we alleviate? Can we use some method? We talk about TCI. There are so many people are epileptic patients. Treatment is going on. There are very many techniques. Can we try to find a method exactly to identify what triggers epilepsy? Can we overcome that? There are traumatic events which are occurred in the individual's mind. Can we pinpoint that this is a traumatic area? This is stored. I will use some eraser to erase it. Can we do it? These are the challenges which are there. There are so many answers for that, but how we are going to overcome all those things? This, I think, probably yesterday we might have talked about it. This is how the process, when registration occurs, how the process, it is in the continuation from sensation, that is accepting the energy source which is coming from outside, and once that energy is received, the perception occurs, where the interpretation of those energy sources, visual, tactile or kinesthetic form, then we pay attention to it, whether it is a sustained or a continuous attention, then automatically once you attend it, it goes into your memory, whether it is a short term memory or a long term memory. We all have, then when attended matter is stored, after that, that is kept as a learned one, and stored memory helps to learn. Then that memory helps to solve the problem. 2 plus 2 is 4. How do we do? That is what is problem solving. And then you uses that becomes your intelligence. We call it as which moderate your decision. It may be that, like in certain situation, maybe 1 plus 1 may be 1. You cannot use all the logic. For example, like if I say that, like you all might have heard about it, syllogistic reasoning and all, like the reasoning, very many things. All men are animals, or you may call it as all men are animals. Some animals are, or some animals are women. All men are women. Is it logically correct? When you ask your computer, it will say correct. That is the difference between your computer and we. We know the difference. We see the social perception. So that's why I say that the intelligence is that. That we want to identify. How it works. Human learns that, uses it, how logically interprets it, analyzes and applies it. It affects. That comes in the form of a behavior. That is the effect. You show different emotions. Why you show different emotion? Many of us doesn't know how to express our emotion. We have not learnt because of our social milieu. Somebody comes and tells you, oh, you are looking very smart. How many of us know how to accept that? Oh, you have done wonderfully in the exams. How many of us know how to accept it? We don't know. We don't know how to express. Either we may be, nahi, aisa nahi hai, right? This is what is social. See, emotion, we don't know how to express our emotion first. So, we have to understand. First, we have to understand that how the emotion, what is an appropriate emotion to be expressed at what point of time. Unless until we know that, then only we can create something different. So, for which we have to understand the affect aspect also. Sorry. So, the level of analysis, you all know that the mental representations are organized in categories, and the mind contains all sort of mental representation which is stored in the memory. So, whatever is there, we try to make a mental picture of it, and it is stored in our brain. After that only we start processing. That is, we call it as cognitive schemas. The schemas are made and it is all stored as a mental representation. It is like a carbon copy has been made, which has been put in the back of your mind. And the mental representations are how we store images and ideas in the memory. We have got different regions to store those things. So, that is how. And what we already know, the cognitive schemas affect the way we interpret the event and stored knowledge in our memory. So, this is the process which is taking place whenever we try to think about mental representation, and the representation and the processes guides our behavior, how we act, react, all those things comes in. Again, as I said, the social cultural factors contribute for the cognitive processes. Each society, we have been taught. That is why many of the psychologists challenges that. You give me 5 people, I will give you doctor, engineer, criminal, lawyer, everybody. One of the great psychologists, he challenged people, but it has been proved, it has been proved other way around. But what I am trying to say is, in order to understand, we have to know all these aspects of it. So, which you all know that, like all these aspects, which majority of you are aware, probably I think that sir has explained you for past 2 days about like what are the facilities you have got. We have facility in our institute, we have a facility at INMAS. We try to understand that what are the cognitive factors which are affecting the human behavior. Particularly, we tend to study the behavior. For example, if I want to have a person who has been suffering from some kind of a trauma, we want to identify that what particular point of a brain gets affected. Somebody goes into depression. What are the changes which are occurring when the depression occurs in an individual? Probably he has made an attempt to commit suicide. See, problem is for us, it's each and every individual is important. I cannot afford to waste any person. Suppose if the individual is having a problem, if they can give me some kind of an idea or knowledge, I can first identify those symptoms by which I can prevent them doing anything. Because he is keeping a deadly weapon in his hand, he is authorized to keep. He can show it to you or show it to me, I can do anything. So, I have to keep his mental well-being in a balanced manner. So, for which I have to understand. We try to study, for example, night vision capabilities. People talk that like all your equipment, you all create lot of equipments. Night vision, you can see night human being moving and all, but it is in what color? Does it give me color? It has got a different philosophy, am I right? It radiates heat, from the heat it is the images are generated, it is given to me. Can we come out with such a thing that which a normal human being is capable of doing that one? Can I train people? Can I cognitively train them to adapt? Being is naturalized, he is able to see those things. There are people who are capable of doing that, I have learned. There are people, camouflaged objects they can very easily detect. Is it possible for me to train them, identify people? So, these are the challenges which, and what kind of a thing if I camouflage nobody can detect it. How do I do? Again, how you are going to affect, how many colors? It is like a water. What is the color of the water? What is the shape of the water? Okay. Now, it is put in this, it becomes a shape. I freeze it, it will give a shape. If I heat it, it will evaporate and vanish. Again I mean try to take it in, I cool it, it will become water, right. Likewise, there are many things which are not known. We have to, as a scientist, we have to explore those areas, and definitely we will be able to come out. And that is what we are doing. We are doing that fMRI, and similarly for transmagnetic stimulation, again transcranial magnetic stimulation. I think that majority of the medical students will appreciate that the epileptic patients, there are so many people. There are so many people are like having, as I said, that like I mean brain injury, head injury patients. Can it help them to lead a normal life? Can we come out with a simple equipment which will facilitate them to do the normal activities? This is the areas where probably you can do it. And even all these things, as I said, that probably you come out with a chip. Earlier and all, like when we go, even today people challenge it. All your devices are working on electricity or else some battery, right. You go and you have got a BP machine at your home. You go and keep your finger, maybe or attach it. It pumps it, like it gives you your BP. If the cell is weak, what will happen? If your charger, the pencil cell, when you put inside, if it is going to be a weaker one, what will happen? Your parameter is gone, right. That is why doctors, even today when you go to hospital, they believe in their own conventional. Can't we come out with such a method which can really a reliable one? This is what is required. All these signals, probably there are so many things which are there. Can we have a compact one which can really send? Earlier and all, when you go to, I mean for EEG or ECG, they used to clean your, I mean put some jelly, and after that electrodes are put. Now today you have got a dry electrode, probably you can use it, but to what extent, whether it is reliable. As I said, what we did, like now when I wanted to use on pilot, nobody would like to have that intrusion. How do I avoid? So that he is not conscious, because that gives an alert signal again. If I am conscious, when you put something on me, I am conscious. So automatically my alertness will be there in my brain. So that is not a reliable data. Now how to overcome? Now you put, generally they wear helmet. You put a helmet, inside that you put a probe. He doesn't know that he is wearing a helmet. He is always there, right. Now non-invasive, how to do a eye movement recording? Because you have got a peripheral vision this much only, whereas pilot will move like this and all. Now how do you check that one? You put a strip of eye movement, try to capture his where and all his saccadic eye movement, where his pupillary diameter which is coming out. So you can record it very easily. So this is how, when you design, you bring your ingenuity and novelty in designing an experiment, so that you will get an accurate data for that. So that is what I just wanted to tell about. Okay. Now let me go further. Okay. So you all know about like Penard's case. Okay. Similarly, what Dr. Ramchandran in his studies also he might have mentioned about. So basically, he met with an accident. The iron rod crossed the left cheekbone and the skull, damage of the frontal cortex. Kate's personality altered after the accident. Total loss of social inhibition which occurred. There are many people today who have had head injury patients. They are available. Can't we help them to lead a normal life? Forget about other things. Can we make them? By studying these things, we can understand how the brain works. I will tell you an example, like a person who was posted in a different altitude for a longer time. When he came back home, I told you about like the memory loss, short term memory loss. He comes, he forgot to apply the brake, met with an accident. He is a wonderful person. He is a very good driver. He used to drive in such a terrain, but when he came to Chandigarh, in the road, he committed a mistake. There was something went wrong. Why it is? How long it is going to have? That kind of a thing. Probably there is some vacuum. I don't know. Only physiologist and the neurosurgeon can say about it. Can we prevent that? Can we enhance those brain activity, those areas? Again, we like physiotherapists. Like any stroke, the individual is not able to walk. Right, and he has given a physiotherapy to get it activated, and those regions get activated, right? Likewise, can we do something to bring back those memory, all those things? That is another area that where it is important. Which this is a model that which Das et al. In India they have studied. It is how the process, the sensory inputs are pumped on it. It goes to second functional unit where both it is an occipital, parietal and temporal posterior regions get activated, both memory, conceptual and perceptual thing, both simultaneous and successive processing takes place, and it goes. This is how he came out with a model, tried to understand the cognitive processes by which we have designed a lot of tests based on this to check the individual's cognitive abilities in the armed forces. So that you require higher order of mental process by which we took this model, we have come out with different kind of a psychological test to check those things. And that is how this cognitive assessment system has been evolved to select people, to screen people. It is not that I can say to screen them, we need to have a threshold level. So that is how we came, both the planning and attention, both the tests of simultaneous processing and the successive processing we have evolved. Based on this model, we have come out with number of tests in our institute also. So the operations which we all know that basically the sensation and perception, how this operation which is taking place, and you can see that which refers to transduction of physical energy into a preliminary neural code that can be further processed and transformed over a period of time, which I mean probably you all know that the schema, how it operates, the cyclic perception operates. Again you could see that from the environment you get lot of input which is modified, the schema takes it, and again you try to explore it, and the samples are sent to the environment. Like that it keep on updating the input. The process of transformation operates from the moment of sensory registration, and it is not possible to draw a line where the sensation ends and the perception begins. So it is just almost an overlapping thing. That is how the pattern recognition came. Basically the pattern, we register all those things in a structured manner, and then it goes into us, and based on that we process the stimulus and come out. And again the pattern recognition, you all know that top down and bottom up pattern recognition. The top down approach is the expectation, the cases of process, finding a match between the stimuli and schema which is stored already in your memory. That is what is top down. And bottom up is there are data sets which are available. Basically a computational science people, they uses that in order to understand the process which is taking place. Again the perceiving objects in the scene, the Gestalt principle will come, that the proximity, similarity, continuation, and the overall final product comes in. So generally we have got, always it has got the proximity effect, after that the similarities, then the continuity effect, and finally we come out in the final decision making level. That is how it is a figure and ground as well as grouping concept which we uses in order to understand the perceptual process. This is also being done. And attention, we all know that there are so many kind of an attention, whatever is it is sensed, all the things doesn't gets your attention. When I see all the people, if somebody is just turned behind, you can very easily make out that your attention is focused on it. So where that spotlight comes in. So that is how the attentional process which is taking place, something unique which attracts you faster. If you try to come up you cannot identify that one. So even that facial recognition, all those things, many a time people start using it. What we heard is, I think that some time back there was a thing came when they want to use face recognition in a Chinese market, probably they faced a lot of difficulties, because the Mongolic feature doesn't give the facial expressions in a different way. They find it difficulty because many people had a problem when it doesn't open. They have to redo that process and do it. So that's why it is all depends on how you process those inputs. That is why it is important to understand about the attention also. Again you say that filter theory, again it says that whatever information comes, it's filtered only selectively, it picks up, it goes and it is processed. Then came the channel capacity, whether you process the channel both auditory and visual together, or even within visual itself how many you are processing, successive, all those aspects come. So early selection, attenuation and late storage. These are some of the theories that which will help you to understand when you try to design any kind of an experiment. Then comes the capacity. Capacity theory is that
how much capacity you have got, residual capacity you have got to process those information which you are attending to it, how you are going to process that one. That talks about the signal capacity model, which is allocation of resources. We call it as time sharing. Your mental faculties are assigned certain things. Okay, you take care of this, I will take care of this, like that. When the channel is get mixed, then the problem comes in your decision making, your processing of information. So you have to understand. There are automatic process, that also the various theories are there. I was just going in a much faster way. Okay, this again I don't want to again work on it. Sensory input, working memory, and it goes to long term memory. See, many a time we have got problem. When if I say that Ram, immediately all our thought process will go to Ram in Ramayana. Am I right? Because it is the association, like now we have got. But probably one of your best friend may be your Ram. Suppose it is like context specific, how we interpret the information. So you have got a huge library in the back of your mind. It goes within a short span of time, it checks out all the things, and he says, okay, you are talking about our classmate Ram, immediately, right? So when the context, if three of you meet, you talk about Ram, they all think that okay, our own batchmate Ram ke bare mein hi baat kar rahe hain, like that. So your resources are allocated. So that is what is most important. Again, this is stored in this way. It is an environmental input. It has come as a visual, auditory, and the kinesthetic one, and it goes to short term memory. Again, short term memory is for a short period of time it is available with you. After that you will tend to forget. I will ask you one thing, that there are many instances. I want to ask you one thing. Yesterday you are all here in this institute, this place, you are listening to lecture. Please tell me exactly at 5:55 what was the talk which was going on. I asked what was the talk exactly. Is it like this memory, like that? Because that's what is selective. Same thing if I ask you that, like, no, for example, I will just simply ask somebody that, probably if I ask them that what happened to you when you were you were a child, some important incident you tell me, memorable incident, you will narrate. I went for my birthday party, it was 6 o'clock, so many friends came, I wore that dress and my friend pushed me down, so I got a scar here. You will narrate entire episode of that. How is it possible? So for that purpose, this is the process. It talks about rehearsal, coding, decision, retrieval. You recall, remember, rehearse it, repeat it, automatically it goes to your long term memory. From there you pick up those inputs and then you give your response. That is how the brain works, and then memory functions on it. And acquiring, learning, there are so many ways of learning the thing. Because I am running out of time, I have to just do it. You all know that classical conditioning and the operant conditioning method. You all know that it's very easily that when unconditional response and the conditional stimulus and response pattern, how Pavlov worked with the dogs, the saliva and the excretion rate, based on that he could condition the dog. With unconditioned stimulus he can produce a conditioned response kind of a thing. So this is also one kind of a learning. The reinforcement strategies, everything came through the learning process only. And again, the operant conditioning is also associated response and its consequences, because it's a reward punishment mechanism. Basically you tend to give a reward, automatically that goes and stores in your long term memory. If I withdraw the reward, again it is a punishment. Don't think that every time I give a Cadbury chocolate to you, it's a reward. If one day I brought and I say that I am not going to give it to you, that's a punishment, right? It's not a reward, it's a punishment. So automatically, so this also modulates our behavior, our storage capabilities, and based on that you are going to retrieve it at a much later stage. Then similarly, the observational learning, generally modeling, it is an imitation of a specific behavior. The chimpanzees, lot of things which they do, lot of experiment, even our own behavior, we are all imitating. I can tell you one thing, how many of us are comfortable? I will tell you one thing, you try to wear, like in a summer month, you are asked to wear 3-piece dress and come and stand here. How many of us would like to walk in the road? We are aping the Westerners. We forgot our culture. We forgot our tradition. I will tell you one thing, I will give you a chapati with dal in a plate. I will give you knife and a fork. Please eat and show me. This is a difference, right? There are so many things which we tend to forget our own and then try to imitate somebody. This is also imitating observational behavior. There are some of things are positive, constructive, helpful behavior. Some of things are totally on the other way. It has got both equal. Learning has got both equal things in us, right? So, expertise. How we acquire expertise? These are the process. Sometimes is it innate or is it acquired? You are born with a silver spoon or you have acquired over a period of time. Lot of things. We have to understand that where, if it is innate, where it has been stored in our genetic, is it in the genetic morphing, does it code it somewhere? So, like that. Expertise refers to mechanism of underlying superior achievement of an expert, that is one who has acquired special skills or knowledge of a particular subject through professional training and practice. Repeated practice, repeated learning. I told you that, like I gave an example. I read the same Hilkard and Atkinson book, and as I told you that I am able to understand maybe 10%. After so many time reading, I am able to understand what was there in the author's mind when he was writing that book. Okay, it is not the concept I am talking about. So, it takes lot of time and effort to understand. So, that is important, then only you can become experts are skilled and mnemonically encoding information. They use a different way of encoding information. You all must be knowing that how to keep 10 items in your memory. The simple techniques which are available, mind training technique probably you might have heard. You try to relate your room, entrance of the room, okay, where you keep your vehicle key, where you leave your shoes. You try to associate it, you are able to remember almost 20 objects in no time. You can become an expert one fine day. That is how you train your brain to process the information. That can be done. And highly effective strategies for retrieving information, different brain structure activation while performing novel tasks and well practiced tasks. What we do is, a novel task requires an alertness. I mean, this is well practiced task does not require. First time you are learning a cycle, how many times you have fallen? After that, you do not tell your brain that you turn left, you hold your handlebar, you keep it straight. Am I right? Bike or cycle, you hold straight, hold it tight, as if that if you keep it tight, no, it will go straight, you will fall. After that, you leave both the hands, you will be coming, you will be talking to somebody, automatically you turn. It becomes an automated response. So, you all, I mean, from physiology side, you all will do. So, that is the thing, that differences in metacognitive ability and expert and novice, which could be seen very easily. These are some of the things which I thought. Language acquisition is another important area where, like different rules, a system of symbols and rules that enable us to communicate, that help us to communicate in a different way. A process of attaining a specific variant of a human language. Every language has got certain scripts, and then that is taken. Again, when you pronounce it, you can do a small experiment. You will pronounce it. It may be meaningless words, but you are able to identify the right response. Put the symbol and you ask them, you just use the sound like this. Probably people, it has got like that innate thing. It is there within us. Automatically you are able to do that one. So, that is what is important. Baby imitate a parent, and if it is reinforced, keep saying that word. If punished, stop saying that word. That is social learning theory approach. Similarly, inborn universal language acquisition device, nativist theory, the Chomsky theory. This is most important thing to understand, that how the speech recognition and all those aspects. It's a beautiful theory which he has given, by which we are able to understand and try to communicate to the things very effectively. And language determines the way we think, that Wolff's linguistic relativity. That is what I was talking about. The Hopi tribe has got no past tense, so that they talk in present always. Think in they never think in the past. That is how it's coming. Thinking and problem solving, there are different kind of a thing. We know that nowadays all this problem solving, we can use the computer language, we can develop algorithms to do that one. But heuristics, rule of thumb, fast but prone to errors at times, it so happen. But the hurdles in problem solving is that all of us have got we have got a perceived mental set within us. That is why I say that you have to erase it and learn new things. And functional fixedness, we are fixated at certain places, we never want to see in other way. That is why like no, you do not understand. What am I saying? You do not understand. We tend to tell, why is it? This is what. And confirmation biases, always we expect that somebody has to give approval to us. These are the biases. And framing, all these aspects are the hurdles for solving a new problem. You can see that the sequencing which is given by which you can understand, and these are the research domain I feel that which are most important, and we all can contribute for that. The cognitive profiling, to what extent and what are the constraints in it, we have to understand. If I want to profile somebody's cognition, how to profile, what are the ways and methods. Similarly, cognitive style, everybody has got different cognitive styles to understand, read, recite, reproduce it. Somebody you will be seeing that like no, he always has a habit, I should have a music on or TV on, then only I can read. Exam, there are people who go the next day morning is your exam, he will go for the late night show, he will come coolly and do it. There are people you will see that like no, in front of just the exam, this is the exam hall, up to this I will be reading. Okay. There are different people. There are people who do not even come to class, they will be stopping. You will wonder how what made him to do that. That is why I say that these are all individual, we have to understand. And cognitive failure occurs. It happens with every one of us. We have read, all of a sudden everything vanished. What is it? Cognitive regulation, how we can regulate our mood pattern and things like that. Cognitive engineering is another important area. You can produce lot many tools to do that. Cognitive restructuring, I told you, you can modulate the mood pattern of an individual, the emotions of an individual, that is most important. And sorry, again cognitive aberrations, what are the things which occur? Multi-skilling is another area, cognitive retraining is another area, PTSD cases probably. Cultural cognition we must understand in order to make people effective, and decision making, and ultimately metacognition. All these are some of the domains in which we can work on it, and definitely we can come. The process which I said, that the threshold of mental load, every one of us, how much time material I can take it, how much time I can sit in a class and acquire knowledge, it is not that. So, multi-skilling and emotional regulation. When you do a multiple job, you have to regulate, you have to deal with varied kind of an environment. The environment stress is there, your own personal stress is there, your own social stress which is operating on you, how, and you have to do the job also very effectively. How you are going to do it? An ATC controller, I was talking about it, how he is going to. There are so many people in his hand, the lives are in his hand, how he is going to do. Then the task specific cognitive profiling, each task requires a different level of a cognitive skill. If we are able to use that effectively, he will do well. Otherwise, always we say that like no, we have got a proverb, am I right? The ideal mind is devil's workshop. So, we have to keep people engaged. So, automatically you need to have that, and cognitive restructuring in extreme environment and high tech system, and this is important. Suboptimal conditions, I am talking about extreme environmental conditions, where if the individual, suppose you want to send somebody to space, somebody to the Antarctica, Arctic or things like that, where there is no human being, what kind of a thing? Preparedness for modules for special forces, dissonance and restructuring for those people. These are the things like no, these are the things, reaction to information and rumors. This is what is the future. Everybody is taken for a ride, they spread rumor. How to make people insulate from these kind of a rumor, how to make their cognitively ready to overcome that one. Complex environmental operation, camouflaged object detection on sea, terrain, clouds, these are some of the areas we are interested. Coming to decision making also under stress and time pressure, most important. How to enhance this decision making process and capabilities, and risk and ambiguity. We in high risk area, totally ambiguous, you do not know whether he is an enemy or foe, what action he has to take, and cognitive load in decision making. all these areas. Metacognition I was talking about, own thoughts and factors influence our thinking, the strategic decision making in complex situations. Today you have to take, because today India is going to emerge as a global leader. If that being so, you are looked up, you have to take. There are critical situations. When you say yes, you will be taken for a ride. So, but at the same time you have to maintain the relation. So, what kind of a thing? Overcoming judgment biases, synthesizing information load and leadership style, where we can contribute. We can identify by understanding his metacognitive level whether he could be a potential leader. You need leaders. So, who could be a leader? All these things we can work on it. Multi-skilling also I told about it, and basically these are the things, the issues, major issues in cognitive research. Process involved within and between mental function. We have to identify behaviors and their cognitive representation has to be understood appropriately, and differentiating localization, regionalization and lateralization is another important aspect. Knowledge about the tool and technique specific peculiarities when we try to apply it when we do a research, and design specific and the nature of study. How robust we are designing, so that there are certain aberrations should not come and contaminate your data whatever you are getting. So, what kind of a robust research design that you use, and knowledge and treatment of outcome measures, how we interpret the output whatever we are getting in a much more sensible way, logical and a rational way, then only that can be applied effectively to the humanity. Otherwise, it is not going to help us in any way. Basically, like the emphasis is that I thought that why I wanted to tell all these aspects is because you are all from varied discipline. Maybe many of you may not have read psychology, or some of you might have read psychology, but these are the basic aspects. If you are